Good morning, and a warm welcome to all our dignitaries who are with us today and to the audience in the seminar hall. Our chief guest, Dr. Shashi Paja, Honorable Minister, will be with us shortly, but she has given us permission to continue with our program. She will join us. She's attending to an emergency. She will join us shortly. We are very privileged to have with us Dr. K. Rajkumar Kasalingam, our chief patron of the program today. And could I invite you to the dais, sir? Can I invite our principal, Dr. Madhumanjari Mondol, to the dais, our vice principal, Dr. Shupratim Das, to the dais, Reverend Pakhare to the dais, please, and Dr. Shamrat Bhattacharjee, our IQAC coordinator, to the dais. As is the convention, we shall begin with a short prayer to be read by our chaplain, Reverend Pakhare.
Good morning, everyone. Good morning. Are you prepared for today? I believe all these wonderful people, gifted people are here for you today. They want you to enrich. You know, they are here to be, to bless you with all the knowledge that they are going to impart with you. So you should be ready now. Okay, let's pray. God, our loving Father, we want to thank you for this day that the college, which is renowned, which is known by Scottish Church College, and the learned principal and all the faculty together, jointly organized with the Government of India Rubber Industry Research Center. Gracious Father, as this is going to edify these young minds so that they can be wonderful researchers and innovative in their days to come. Loving Father, commit these all young minds into your mighty care, because we want them to be blessed all the time. We want them to reach out to the heights where you want them to be. Only sincere hearts, faithful minds can reach to that height. So Lord, give them that wonderful time to learn and understand the importance of every study that they go through. At this moment, Lord, we are also grateful and thankful to you for these wonderful faculty who have come from all different parts. They are here to impart knowledge. Bless them, Lord, because they have come in your chosen and wonderful college, where the education is always highly regarded. Be with everyone, O Lord, as they continue to do justice to this wonderful program. Bless everyone. Let your peace, let your wonderful guidance reach to the hearts of these young minds and let them be benefited. We love you and we thank you. Be with us throughout all these sessions. For we ask this in Jesus Christ's name. Amen. Thank you.
May I now request our chief guest, our principal, vice principal, Reverend Pakhare, and our IQAC coordinator kindly light the ceremonial lamp. Professor Tamanna Sultana and Debaroti Dey will assist them. We are being joined by Mr. Devditto Basu and Dr. Chandan Kumar Pal. And Dr. Saurabh. Thank you to all the dignitaries for lighting the ceremonial lamp and officially beginning the program. May I now request our principal to give the official words of welcome.
Good morning, everyone. Honorable Minister for Industries, Commerce and Enterprises, and Department of Women and Child Development and Social Welfare, Government of West Bengal, Dr. Shoshi Paja, who our chief guest today's program. She will be joining shortly with us. And today, our chief patron who is with us, he is Dr. K. Rajakumar, Director, Indian Rubber Material Research Institute, Government of India. In spite of his busy schedule, he has managed to come to Kolkata from Delhi, and we are grateful to you, sir. Two of our former students who have come from IIT Kharagpur as honorable speakers, Professor Kingshuk Noshkar and Dr. Titash Mondal. They are coming inside. So Kingshuk and Titash, we are welcoming you. Honorable speakers who have come on behalf of IRMRI, Mr. Shondeep Mitra, Business Development Manager, Walker Network Chemical Private Limited, Sri Kamlesh Jain, Managing Director, Wholewell Components Private Limited. Then speaker from Scottish Church College, Dr. Rupendranath Nundi, Faculty, Department of Physics, and he is our bursar of this college. Honorable panelist for the panel discussion, headed by Mr. Navratan Jhawar, industrialist. Thank you, sir, for coming. He is our IQAC member also of our college. Professor Dipankar Chattopadhyay, Department of Polymer Science and Technology, University of Calcutta. Professor Ovijit Bandhopadhyay, Department of Polymer Science and Technology, University of Calcutta. Mr. Kamlesh Jain, Wholewell Component Private Limited. Mr. Kamal K. Chowdhury, MKL Polycoat Private Limited. Dr. Devditto Basu from IRMRI Kolkata, with whom we have planned everything. He is the nodal on behalf of IRMRI for this program. Dr. Saurabh Chakraborty, who is the nodal on our behalf from Scottish Church College. Dr. Chandan Kumar Pal, Head of the Department of Chemistry, who is also one of the organizers of this program. Our Vice Principal, sir, Dr. Supratim Das, our IQAC Coordinator, Dr. Shamrat Bhattacharjee, our Senator Secretary, Dr. Vidisha Sinha, Teachers Council Secretary, Dr. Indrani Kaur, and all faculty members of Scottish Church College who are present today, who are actually the different committee members and who are helping us a lot. And there are many members from IRMRI Kolkata who are also with us today, distinguished guests and the participants for this first academia industry outlook or interface of Scottish Church College in collaboration with IRMRI. On behalf of Scottish Church College, I welcome you all this morning. After signing of the MOU with IRMRI, this is the first program we have organized jointly. I'm really indebted to Director Sir for his cooperation and his gracious presence for this program. The institution like us, which is almost 196 years old, on 13 July this year, the institution will celebrate its 196th Foundation Day. It is really an auspicious moment when for the first time our chemistry department has hand-holded with such an institute like IRMRI to enter in the field of rubber industry, to do some research work which will be the need of the hour of different industries of India and all over the world as well. This is the first academia industry interface we are organizing in this college. In this regard, we are grateful to our renowned and experienced former students who helped us a lot. I am grateful to IRMRI for sponsoring the lunch and the kits for the participants for this seminar. I hope the participants will be able to learn a lot through this exercise, and the participants for the poster competition enlighten us on the topic of today's seminar, that is materials today in perspective of sustainability. I wish all the best to the organizers, speakers, and participants from the core of my heart. A very big round of applause to all of them. May God bless us all. Thank you.
Thank you, ma'am, for your warm words of welcome and also sharing with all of us certain ideas about our college and what it stands for. And now it is a special privilege to felicitate our guest of honor, Dr. K. Rajkumar, and I will request our principal to do the felicitations. She will be assisted by Professor Tamanna Sultana and Debaruti De. Thank you, professors. Thank you, ma'am. Our principal would like to felicitate all the other speakers over here also, because she may not be able to be here later on in the day with her various engagements. So I would, Mr. Shundip Mitro, Wacker Metro Chemicals Private Limited, he's going to be one of our resource persons and we are very grateful to him. He's in one of the, #1 silicon product company. And he's also one of our alumni members. Dr. Titash Mondol, IIT KGP. He's also, so this is like a homecoming for you. Mr. Kamlesh Jain, Holdwell Component Private Limited, who is also going to be one of our resource persons. Dr. Upendranath Nondi, who is our in-house representative on the speaking panels. He is the Joint Director, Research and Development of Scottish Church College. And the stalls that we are felicitating you with have been made by our students. We have organized batik workshops for them, and our students are working over there and producing these. So I think they also deserve some recognition for the great work that they are doing. Mr. Navratan Jhawar, Suncrest Industries Private Limited, who is also a panelist and a moderator. Welcome, sir. Professor Kingshuk Noshkor. He's from IIT Kharagpur, and he's also an esteemed panelist at today's program. Oh, you're also welcome as an alumnus. If I've missed out any speaker who is here, kindly bear with me, and it is my special privilege to also introduce Dr. Rajkumar Kasalingam to you. Though he needs no introduction, I understand MSc, MTech, PhD, MBA, the degrees speak for themselves. He is presently working as Director, IRMRI, Ministry of Commerce and Industry, Government of India. He has certain special roles. He is Chairman, BIS, PCD 29 and PCD 13. Total work experience he has of 27 years, and he's involved in indigenization of projects for defense and nuclear sectors. He has more than 30 publications in national and international journals. He has received appreciation from Nuclear Recycle Board, BARC, for indigenization of rubber gauntlet. IRMRA Meritorious Cash Award for successful development of polymer gauntlets. He's received the NAIP Award 2012 for successful execution of rubber dam project sponsored by World Bank from ICAR, Ministry of Agriculture, Government of India, from the hands of Governor of Goa and Minister of MP. Had nobility of attending the JRMA seminar at Japan as Indian technical expert on behalf of BIS, and received appreciation from President Japan Standardization Committee in the year 2006, 2007 and 2014. He has also received the Bharat Seva Ratan Gold Medal in the year 2016 from GEPRA. He is also an awardee of the ISO TC 45 Long Service Award 2019 for contributions to international standardization. So, ladies and gentlemen, I welcome our guest of honor, Mr. Rajkumar, and I would invite him to say a few words.
Very good morning, Father Martin, Madam Mandal, Principal, Dr. Das, Vice Principal, IQAC Coordinator, Dr. Bhattacharjee, distinguished guests, esteemed academicians, respected industry leaders, of course, Mr. Kamlesh Jain and Dr. Jawhar Saab, and faculties from IIT, Professor Kinsuk and Professor Titas. My dear students, good morning to one and all. It is my privilege to stand before this august gathering to address this particular forum on a topic, materials today, that is towards sustainability. that everywhere you go, talk about the sustainability. It's okay. Hello? Okay? Yeah. Always I have pleasure in addressing the students whenever possible, because they are the future leaders of this country. Future faculties, future industry leaders, future politicians and whatnot, basically. So, I would like to congratulate the Scottish College, Scottish Church College, for having organized this wonderful event jointly with the Indian Rubber Materials Research Institute. As Madam said that we have signed MOU. I think I would have signed more than 40 MOUs during my tenure as director. But hardly I visit back to the college after signing MOU. This is one among that. I know many colleges sign MOU with institutes like IRM or I just to score academic for gaining the marks during the NAC accreditations, UGC score, etc. Only few gets transformed that collaboration basically. So in that way I am happy that this college is one among such college. That shows that your inspiration and involvement in real academic collaboration with industry basically. So my deep appreciation for such organizing committee along with my colleague Dr. Deptipta Basu. The moment he said that we are planning to do it, I said immediately do it. And he asked me that, sir, you must come. I said I will come but I cannot commit. Believe me, yesterday evening I booked the ticket. Otherwise I had to go to Delhi and day before yesterday I was in Cochin, before that I was in Delhi. So unfortunately my travel is such, and I was really not sure whether I would be able to make it. I am very happy that now, once I am here, I am certain that's the thing. Not that I don't want, but the schedule, the priority makes that thing basically. But I always said that definitely I try my level best to come basically. And my return is today evening, I think 9 o'clock flight. So I'll be reaching home at 12 o'clock. So, coming to this topic of materials, I recall that once upon a time, not very long back, but about 25, I think 35 years back, I was the student like you in chemistry. I never imagined that I get into a rubber technology from IIT Kharagpur and then pursue and then I become like this. Many times what happened, the chemistry students, they get into the college because for many compulsions or maybe they like it, we don't know. Because our friends take it, so they take it. They don't know that which are the openings after the chemistry basically. In fact, before I end up IIT Kharagpur, applications, that there is a division called rubber technology. And rubber industry is such a huge, I never know. I was a chemical sciences student from Pondicherry University. What I know that basically, I was dreaming about IIT. I couldn't get IIT BTech because those days the coaching classes were not so famous. There was no WhatsApp, there was no mobile rather. And so, otherwise it would have been familiar basically. So we never know that basically. Even RECs are very rarely there those days, now so-called NITs basically. So, but one of the professor used to say that those who regret that they could not go to REC or IITs, there is a lateral end scheme. So if you want, you can still go basically. He said, so you study well in BSc, get into the good MSc, good college or university department college, and then write GATE. Through that you can reach IITs, lateral entries. So I was one of the such successful student of chemistry. I got into my National College BSc Chemistry, then MSc Chemical Sciences from Pondicherry University. Then I had options. After MSc, my grade score was 99.14. All India rank was 15, basically. And that time also I don't know whether I should go to rubber technology or polymer technology or biomedical engineering or material science. There are so many options. Again, the guide was my seniors. The immediate seniors, and they say that basically you have these options, where you want to go, basically. Then I selected the one and only IIT Kharagpur, which offers rubber technology. No other IIT offers, even today, basically. So be unique. You can select such a unique field so that you are noticed, basically. So that is the way that you can select. But as I told you, when you start your career, you are into field where just start career based on your own choices which come on your way. After that, you select the best way possible, basically. I am happy to note that the alumni of this college, like Professor Kinsuk and Professor Titas, even Dr. Basu, so many alumni are coming back to such institute to motivate the students of this college, basically. You don't get, sometimes I regret that I could go back to IIT Kharagpur once or 2-3 times. They called me, invited me. And of course, universities and other colleges, I visit as alumni meet, etc. But this kind of opportunity you rarely you get, actually. But that is very important. That, and you know, after all the technological things, still people prefer to go to IIMs to get the very high score for their in terms of notable industry leaders or even otherwise. You talk about the highest package in the industry. I know one of the alumni is sitting here in IIM. So, Mr. Kamlesa, basically. So, the point here is basically the advantage of going into such institute is there are a lot of networking. Because IIMs, when they say that they help each other, that alumni help each other to get such a big packages, basically. This I learned much later, actually. Similarly, even IIT also helps. For example, our alumni help each other. If anybody needs job from rubber technology background, we have a big RTC group. We put there and then we get notable opportunities and get mobilizations. So this, at least today it is possible due to the technological, advancement. Otherwise, earlier it was only guided by, the seniors and because many a times our parents may not have that much of knowledge and wisdom, basically. They may not even know that. When I wanted to go to IIT, my father said that hey, many people are coming to REC in, Tiruchi, why you are going there? I said, because I got admission in Tiruchi REC also. No, I said that IIT is better than REC. So like that. So sometimes we guide our parents that what is good or bad, basically. But it's good that today that we have such a notable alumni are coming. My request is to the students, please be interactive with your students. And this kind of interactive meet, organizing such seminars, it is not just to learn certain subject, but also to keep noting those alumni or the industry leaders or the academicians or the speakers who are coming from different persons, different part of the country, and then take the note of them, basically, and then see that how you can get yourself interactive in future and then get into it. Maybe some of you can get into end up into IIT for masters or MTechs or even for PhDs, basically, after your masters, and then going abroad and all the things. So professors help each other to get into such things, basically. So this I thought that I should tell the students, basically. I know professors keep telling, but when other person comes from industry, they tell, that goes into the things, because this is how it takes place, basically. And I don't take much time basically. Indian Rubber Materials Research Institute is one of the leading premier research and development organizations, I can say in the Asia level. Soon we can say even the world level basically. We are growing much advanced level where that academic, basic and applied research and development is happening, closely working with the industry, also the government. So it has that privilege of working, bridging the gap between academic and industry and the government basically. And I, as a part of such nodal network, had a privilege of interacting with industry leaders, academicians, as well as, the government who are taking decision makers of these particular policies and processes basically. So, rubber industry is more than 1 lakh crore economy, and it is getting almost, it will be double in next 5-7 years. India is growing much faster compared to other countries. We have industry stalwarts here to motivate you further, to pull you over there. And then what we say that never be a part of employee, so be the employer basically. So you can become employer sooner. So we also have incubation center at our place. And I came to know that from madam that Scottish College also started incubation center from one of the notable alumni sponsor, and they have done that actually. So be one of the such incubatee to start some entrepreneurship in rubber field. If anything you want in rubber field, you can interact with us, with IIT professors or any industry leaders. And there are lots and lots of opportunities are there. When I say 1 lakh crores economy, still more than 30,000 crores of rubber products are imported, foreign dependent. We are spending 10 times of the value to buy such things basically. So we can make our own product, and we can be our own dependent, and we can employ more people. So this is the opportunity which I wanted to tell you as a students over here. So you are in safe hand. The chemistry is the, very high level of materials today world, and without chemistry nothing works in the world. Definitely, so you get into the rubber or the polymer, which is one of the promising, growing industry. Plastic is much more than the rubber basically. So either rubber or plastic, whichever you feel like, you can take it and get into the industry and then see that actually. So I'm happy to be part of this event, and we should not limit with this college. It's only the small event. I believe that we also have a lot of courses, short-term courses we can organize. Also we have a long-term, that is 2 years course at our place. So any students interested, they can come and enroll there actually, and they can also pursue the research. We also get a lot of sponsored projects from various ministries. So for that we need more, JRF, SRF and all. So anybody who are after the MSc, they can come and join us, either in Mumbai or in Kolkata or in Chennai. So we have networking at different level basically. So that's the kind of opportunity we bring basically. We'd be happy to work with Scottish Church College for future endeavor, whatever we come like. So one of the agenda is initiated as a part of MOU. I'm happy and hope to continue with more and more fruitful association and do that. So with this, I would like to thank the organizing committee and all staff members of this college for having me here, and wish you all the best for the students. And thank you very much. Jai Hind. Thank you.
Thank you, Dr. Rajkumar. I think you have set the tone for the academia industry interface, I would call it. Instead of outlook, I would call it the interface. And this is extremely important in today's world when we are bridging, these two distant parts of our experience. The academia stays in a kind of ivory tower, and the industry is out in the field. And this, you're bridging this gap, and we look forward to more such collaborations that work for us. The other thing I wanted to thank you for was appreciating our alumni. I think Scottish Church College is absolutely convinced that our alumni is one of our assets. So, may I request our Vice Principal, Dr. Supratim Das, to say a few words.
A very good morning. Actually, during the last few minutes, I was very seriously thinking about exactly what to say here, particularly as a social scientist. Because in this program, I see a galaxy of very competent, very knowledgeable, well-known, noted, illustrious resource persons, and particularly Dr. Rajkumar, when he was sharing with us some experiences of his own life that were coming to me just like hands-on training, because such experiences and such memories and such narratives do matter in our life. I remember that in 2004, when the college, Scottish Church College, for the first time went into the NAC, the National Accreditation and Assessment Council visit, for the first time in the questionnaire, which is actually prepared by some outsourced companies, for the first time we came across a question whether there is an industry institute partnership in the college. We had to write no. After 4 years, for the second time we went to the NAC, and again we had to write the same answer. Although we got A. But this we could understand over the years, that this is very much in the air. For me as a social scientist, from this caption, 3 particular words are very significant. One is outlook, the second is perspective, and the third one is sustainability. In business world, of course, outlook is not just taken in the sense of the current, in the sense of the present. It has enough futuristic connotations. Truly it's an interface, but outlook meaning that there are prospects which we can explore in the coming days, in the coming times to come. Perspective is exactly what matters in our life these days. Because today we are living in an ever-changing, a very fast-changing globe. Almost everything is so dynamically, so fast-changing around us. And we are experiencing this, whether we like it, we dislike it, we welcome it, we accept it or not accept it, with no regard to what we expect or not, it is happening and it will happen. That is in the course of history. So the perspective is very important. We must remember that today when we are trying to make a very positive bridge between 2 very premier institutes of the country, surely so many possibilities are opening up. We know that in the context of, in the perspective of any kind of sustainability, and when the question is a question of how to build up a very constructive connection with some companies, industries, then definitely we are bound to face challenges. There must be cultural differences. There must be problems of technology transfer. There must be differing goals. And of course, there must be different types of visions. But we have to come forward. We have to go ahead. Naturally, it is particularly most appropriate for an institution like ours to very quickly adjust to these challenges and make the best use of this kind of partnership. Because without this kind of partnership, academia industry interface, no institution can go ahead these days. That is the order of the day. That is exactly the order of the day. So Scottish Church College is very much now in the process. As the process is in the air and the college is in the process. So college has to go many more miles, and this MOU, as like many other MOUs, it may be very effective, but whether it will be effective or not, how far effective, how far beneficial for particularly an academic institution, everything will depend on how capable we will be of using the possibilities that are now ahead of us. So I congratulate the principal. I once again welcome Dr. Rajkumar. He is such an inspiring person. I welcome all the other distinguished guests and resource persons. I'm of course an odd man out here, because perhaps I'm the only one coming from social science. But these days, everything is holistic, everything is interdisciplinary. The globe has been very small. So thank you all. And I welcome all students, all scholars, whoever are here, coming from different institutes, institutions, different parts. And thank you very much.
So the first speaker is Mr. Shondip Mitro. Mr. Mitro is from Waker Metroarch Chemicals. Mr. Mitro holds his bachelor's and master's degree in chemistry from Jadavpur University. Then he joined as the process chemist executive at Waker's Metroarch Chemicals, an Indo-German joint venture company. He made several significant impact at Waker's for the development of new silicon micro and nanoparticles. Until death, Mr. Mitro has been at various roles in Waker's, like Technical Service Senior Executive for Construction, to R&D Manager and Senior Technical Manager for Silicon Elastomer. Recently, he is the Business Development Manager of India and India Subcontinent of Industrial Silicon Elastomers and Marketing Manager Asia, marking segment of mold making. Now today, he will talk on silicon, or solution for tomorrow's world. So now, I would like to call upon Mr. Shondip Mitra.
I think if we switch off some of the lights, it will be easier. Okay, so is I am audible from at the last row? Fine, okay. So first of all, it's privilege to be here because I was one of the students in this college. Even though I continued only for a month and then I got a chance in JU. So, but still I was a student of Scottish Church Collegiate School. So this is basically coming back to my home. And today we're talking about sustainability. So our former President Kalam once said that sustainability, the first point is understanding. So if we don't understand the sustainability, we don't understand what a sustainability material is, and it starts from grassroots level. So I am representing a company called Wacker Silicones. We work on silicones. Basically, this is a very funny molecule where we don't have any carbon atom at its backbone. So most of the polymers that we see having the catenation, okay, there's carbon in the backbone, but silicon polymer is having the silicon and oxygen in the backbone. So what I will take you through will not make it a boring presentation of chemistry. I will just show how silicon is made and mainly the pictures in everyday life where we are using silicon. Okay. So one Indian consumes 0.25 gram of silicon every day. So now we are more using mobile, we are more using, tablets, and we drive an EV car, we use shampoo, we use, paint in a house, which is a water repellent, we are all using silicons. So it's a very, very funny but hidden polymer that we know. Okay, so let us start. So this silicon was first came in 1904 by a German scientist, and that time it was said a sticky mass of no use. Okay, Messe is a German word. So he didn't realize at that time what a silicon is, right? So then it was in the World War, silicon was used in the jets of the German to bomb. So it had a very negative application when it was first born. So we need to know a difference between silica, silicon and silicone. Because once I was watching a television ad of Asian Paints or Berger, I cannot remember, they just missed the E at the end. Okay, so silicon and silicone are different. So in our earth, you can say that after oxygen, 26% is silicon. So which is in the form of quartz. That's our starting point. So we start from sand. And what we do, we convert the sand, that is the quartz, to silicon metal, which is 99.69, that percentage of purity, which is used as semiconductor in the wafer. And then it is converted to a monomer, which is called silane. And then that silane is polymerized. So all the blue dots are oxygen. So you see the backbone is silicon and oxygen. So how this is made? So it is a reduction process mainly done with charcoal. So we have to take the two oxygen out. And to do this, you need a furnace of 1800 degrees centigrade. Okay, so basically, just as a common sense, we can say that it is an increasing carbon footprint. It's a very bad industrial process that can emit a lot of CO2. So that we will discuss at the late of my presentation, how this is now converted to a green silicon. So this is our plant in Norway, Hola, where we take the quartz, pulverize it, and convert it to silicon metal. That is the first step, using of charcoal. And the temperature of the furnace, if you see, it is 1800 degrees centigrade. This is the first step. And this silicon metal is used, as I said, as a semiconductor in electronics. And then there were two scientists, one called Rojo, who was working in the United States, another Muller, who was working in Germany. Together they got the Nobel Prize of Muller-Rojo process, and that was basically to convert the silicon metal to a liquid form. So you see the reaction is it is reacted with methyl chloride, which forms the dichlorodimethyl and that is the monomer. So it looks very simple, but it's very complicated because it triggered to many intermediates, and then we hydrolyze, and then it is combined to form the polymer. So this is just one page of chemistry, because this is very important to understand what I said. Okay, so first we make the silicon metal, and then that silicon metal is reacted with methyl chloride to form all these four intermediates, which are hydrolyzed. And you see, when you have two hands open, you can join the hands to make the polymer. So that's how the difunctional makes the polymer, the monofunctional is a stopper, and the trifunctional forms the resin. That is how the silicon is prepared. Now, why silicon is a very important? Because if you see the bond strength between silicon and oxygen is 422 to 494 kilojoule, whereas the carbon-carbon bond strength is 348. It means to break a silicon-oxygen bond, you need a very strong energy. And that is the reason why silicon is so much durable. Okay, or it can be long-lasted. So, in Wacker, you just follow the yellow line, because all others are the other segments in Wacker, so we are only talking about silicons. We start from the two raw material, methanol and silicon metal, and we'll end up to more than 4,500 end products. So we can imagine how vast is the application. So those are the different forms of silicon as a raw material which goes to the industry. You see emulsion, silica, glaze, silicon resin, solid silicon rubber, silicon fluid, silicon gum, liquid silicon rubber, which is called LSR. It can form a solid silicon after curing. RTV, room temperature vulcanized silicon rubber, and pellets. And these pellets are used in the plastic industry to combine with the plastic. Now, silicon, as I said, is a very funny molecule. With modification, it can be made hydrophilic, which can absorb water. It can be made hydrophobic. It can have a adhesive nature, because we all see the aquariums glasses are joined with silicon, or it can have a release. So we see stickers where we can easily peel off, which is also silicon coated. Similarly, it can have a electrical conductivity. It can also be insulating. All the big insulators which was once made with porcelain is now converted to silicon. We also have shape retention, deformability, and various other applications like UV resistance, surface tension, heat stability, permeability, and so on. So this we will see more in details when we see the applications. So the first application of silicon is in the textile. So silicon can impart a wide effect in the textile because it combines the long chain to the cotton fabric with the amino functionalities. So you can see the softness, the hydrophilic, the impregnation, like the water repellency, easy ironing, fast drying, okay, color control, crease recovery, stability, flexibility, all these properties are achieved when this silicon is treated. So nowadays, shirts are available which is not 100% cotton, but you feel like 100% cotton because it is treated with silicon. Similarly, in the construction, silicons are used to make this kind of water barrier. It's called impregnation. If you treat and untreat, you can see the difference that water is having a lotus effect. It forms a bed, it doesn't go inside. Heat resistant paint and the paint which are chemical resistant as well as the cartridge. This you can see with the machinery people, they are using this cartridge in the tiles joints. This also protecting water. Then comes the personal care, the biggest area of the use of silicons. Like we know many healthcare, skincare creams which improve the texture, which improves the sensory properties, even in the hair, like shampoo, dye, conditioner, everything. This word conditioner is actually comes from silicon because it conditions, is moisturizing. Because in a hair strand, the silicon deposits, it binds with the keratin. Next, if we go to the home care applications, we see the foam control is the biggest challenge. In your washing machine, when we add a detergent, it also has silicone particles which can control the foaming. Otherwise, the washing machine will be loaded with heavy foam. Similarly, wiping and dish cleaning, these are also fragrance retention. These are also various properties that silicons can achieve. Now there are in the chemical industry, we all know that silicon oil and grease are used for lubrication, foam control, polish. Even in the agro industry, the fungicides and pesticides are mixed with silicon wetting agent so that it can very easily spread with a minimum dose. Shoe sole release, paper release, molding is a very important part. You see the repetition of an object precisely can be made with the use of silicons. And finally the rubber parts. We see a lot of O-rings, we see a lot of gaskets made of silicon rubber. Then we come to the healthcare. So in the healthcare you see baby nipples which can be sterilized, respiratory masks, catheter tubes. These all are made with liquid silicon rubber. So the beauty of silicon that it can withstand a very high heat, more than 200 to 300 degrees centigrade. And also in the prosthetics, wound care, and also the liners, these are made with silicon gels. Finally, it is the power transmission and distribution, which are called insulators. We have seen these insulators which can carry a very high voltage. So silicon has a property, is an inherent property of electrical insulation, which has been used. In the green energy sector, solar panels, whenever we look, the glass are fitted with silicon sealant. Even the junction box is called photovoltaic junction box. These are potted with silicon. A wind blade, that is also having the generator, which is coated with silicon. And the spacers are made also with silicons. One of the biggest use of silicon is the automotive. If you scan a car, it is a normal car, combustion engine. So this is scanning a car. So everywhere from the engine gasket, spark plug boot, airbag, vibration damper, exhaust hanger, so various parts, even the turbocharger hose, coolant, all these are the application of silicons. If I go to the modernized EV car, the silicon use is much bigger because in EV, which is the current trend now, the heat control is the biggest factor because of the batteries. So thermal management is the must use for silicon. For the electronics, wherever we look, we have the printed circuit board, we have the IC chips. Here also heat, because the more we compact the circuit, the more is the heat, and that has to be dissipated with the silicon. Finally, vacuum resin is used in the traction motor. This is one of the biggest application of silicon which is going to the Indian Railway. Whenever you see a traction motor, that is being impregnated the coil, the copper coil with silicon resin, which is called class C insulation. And this insulation class means is a very high temperature, like more than 300 degrees centigrade, it can be impregnated. One of the India's pride is ISRO, and in the ISRO, all the Chandrayans that we made, the solar panels which actually collects the energy for the rover, that glass plate, if you see that blue layer glass plate is joined with an adhesive, and this adhesives can work from minus 55 degrees centigrade to 500 degrees centigrade with the same bond strength, and that is one of the special silicon of Wacker which is used. So we are also doing a lot of futuristic projects, innovation projects at a glance here. Finally, I come to the starting point of the presentation. You remember how silicon is made, where you have a lot of CO2 emission. So Wacker has a responsibility, not only Wacker, all the silicon manufacturers, to talk about sustainability. The application is sustainable, but to make silicon sustainable, there are 3 steps. First is we have to increase the value up, when we have to go for the products which are green. Next, the carbon footprint to be down, and we also have to have a collaboration between our customers and suppliers. So this is the target by 2030, that we have to do 100% value up, 50% carbon footprint down, and 100% collaboration. Now, how to do it? The first step is we analyze our products, checking its toxicological, regulatory, if it is used for tobacco industries, raw material perspective, and then it is disregarded, even if we have a business risk. So we promote towards more green products. That is the value up. This is the second stage, which is carbon footprint down. If you see a silicon process, the raw materials is contributing 62% of the carbon emission. 7,200 kiloton of CO2 is emitted. So what we do, if you see the 66% is from silicon metal production. So we now talk about green silicon. In this green silicon, the energy is used, not the fossil fuel, and also we capture the CO2 emission. And then we also use green energy and biomethanol. So these are the things by which the carbon footprint is down. Similarly, the last part is the collaboration. We use paper bags which is unbleached. It means it controls water. It is the reduction of CO2. We use less amount of metal. 4 kg steel has been reduced in a drum, has a big impact of reduction of thickness. Similarly, the IBC, we use recycled plastics, even in the cartridge. So these are the very simple things, and it has a big impact in the sustainability. So we are on the track for our goal to achieve a sustainable future for silicon. This is the Wacker site in Munich, which is in Burghausen, close to Munich. And we have 26 production sites all over the world, and 2 production sites is in India. Fortunately, both are in West Bengal, and one is at Amtala, and the bigger one is in the New Panagar Industrial Estate. So we are very strongly present in India, manufacturing the silicon and its allied products, And of course, some of the products are coming from Germany, and we are in the process of localization, most of the important technologies for India. So that's all from my side. Thank you. Okay, I give you answer. Lotus effect is basically when if you drop a water on a leaf which is having a wax coating, you see it's spherical, right? So in all the construction material, there are capillaries which we can't see on naked eye, but these capillaries are very important, which takes the inside moisture out. Normally, when we use a non-silicon paint, all these capillaries are blocked. So after some time, what happens? The paint swallow and blister. In silicon paint, that silicon silent particles enter in the capillaries and it anchor to the mineral substrate, right? So it doesn't block the capillaries. So now the surface tension of the solid is changed. So when you put a drop of water, the contact angle changes and it becomes a spherical. So that's why it is called a lotus effect. It's like a sphere of which is doesn't wet, but at the same time it is not blocking. It is called impregnation, and that is the one of the biggest application of silicon resin.
And he is Dr. Titash Mondol, and it's mentioned worthy here that he is the alumnus of this college. So you are gaining your seniors among us, and I would like to give a brief introduction of Dr. Mondol. Dr. Titash Mondol, currently he is acting as an assistant professor at IIT KGP, Kharagpur. He holds the degree in chemistry from University of Calcutta and rubber technology from IIT Kharagpur. And then he joined for a joint PhD program between IIT Patna and University of Houston, USA. Dr. Mondol is the author of several peer-reviewed research articles published in Journal of High Repute and holder of several guaranteed patents filed internationally. Dr. Mondol is also an editorial member of some very prestigious paper like scientific reports. I guess students who are not the research scholar, you have already heard during your master dissertation. Scientific reports, Nature and Discover Nano, Springer Nature, etc. Dr. Mondol has received several prestigious awards, Sparks Thomas Award. He received the Faculty Excellence Award 2024, Assistant Professor level IIT KGP, and IOPA World Young Scientist Summit Early Career Award in 2024. Today, Dr. Mondol will discuss about the electronic applications of rubbery material. So now I would like to invite Dr. Mondol.
Yeah, still morning. Very good morning to all of you, and bit shaky because last time I was in this podium in 2006 when we used to present the seminar. It used to be a compulsory seminar, and I remember one thing very vividly because in our batch we were the first one to introduce the Microsoft PowerPoint based seminar. So that is something we introduced into the college, and it's a homecoming for me actually. I'm very excited. I was just roaming around, and also at the last I heard briefly to Mr. Mitro's presentation on silicon. So today I'm going to talk something on the application of the rubbery materials for mostly electronics actually. Okay. And I mean, what is the rubber product that comes to your mind when you talk about any rubbery materials? If I may ask. Sorry, can any one of you be louder? Don't behave like IIT KGP BTech student. You ask anything, you don't get back anything from them. You guys are from the best college in Kolkata. Okay, mostly you can see tires and all this kind of things. But the application of rubber is something which is even beyond that. It is not something only restricted to tire materials or traditional rings or the pressure cooker gasket, whatever you see, if you see today's technology is like, it's moving pretty fast and the frame is changing very rapidly. So there is nowadays demand of new type of materials always. And what I did, when I joined back in 2020, I'm kind of an COVID batch assistant professor because I joined institute and the institute got closed. I was very unfortunate. Okay, so my PhD students came and joined in 2021 and it was a bit tricky situation for me. So, but thankfully I got much time to think through what are the research areas in which I can focus on. And then I thought, okay, why not some electronic applications of this rubbery materials? Can these materials be used for those kind of applications? So with that, basically my journey of this research work is started. And another trivia, I was just roaming around outside the assembly part. So I find that the connection of Scottish Church College with Polymer Science and Engineering is pretty long, because if you see the medal list what you get outside, in 1931 Shantiranjan Palit, Dr. Shantiranjan Palit won the gold medal, and he is an alumni and he is known to be the father of polymer science in India. And me and Professor Kingshuk Naskar, we are fortunate to be the great grandson academically of Professor S.R. Palit. Okay. So having said that, I'm going to next 30 minutes, I'm going to talk about what we do, rather my students are doing in this particular domain. As you can see, this is my beautiful campus. It's all green. It's a wonderful campus. So today I'm going to restrict my talk to something which is known as the rubber nanocomposites. Okay, I mean nothing to worry much about. It's a very simple thing. So let us begin it. What exactly a rubber nanocomposite means? Okay. So before even we go to the nanocomposite, let us try to understand what exactly a nanomaterial. Any volunteer what a nanomaterial is? Like let's say height of a child which is close to 1 meter. My son, let's say he's 6 years old. Okay, and I deal somewhere here which is 10 to the power minus 9 meter. Okay. So when you take a material of the magnitude 10 to the power 9 meter minus 9 meter, that material is known as the nanomaterials. And you get plenty of examples of such nanomaterials in day-to-day activity, like a lot of research work is being done in that particular domain. Now when you take this like nanomaterial and put it into the rubber and mix it effectively, it becomes a rubber nanocomposite. Very simple. All of you know now what a rubber nanocomposite is. So there are many fundamental reasons like why this nanomaterial is used compared to the conventional material in the rubber. Because these nanomaterials are wonder material, like it can bring in a lot of functional attribute to the rubbery material, because rubbers as such, I mean they are mostly the organically built molecule, macromolecules, unlike the silicons which are the inorganic polymers you can get to see. They are inherently little bit weak. Like it is most like, how many of you know Popeye, the cartoon character Popeye, right? What does Popeye loves? Spinach. So you get a bulge in the muscle as soon as Popeye munches a spinach. So it provides a strength to the material or strength to, the Popeye. So similarly here, this nanomaterials, whatever we introduce into the rubber matrix, makes the inherently weak rubbery material a bit stronger, or I would say make it more usable into the real life applications. Okay. Now if you see, these nanomaterials are very, beautiful. Like if you take 1 gram of graphene, okay, which is like discovered in 2004 by Professor Andrei Geim and Professor Novoselov from the University of Manchester, and they got the Nobel Prize in 2010. It can basically cover up a soccer field, like, of this particular area. As you can see, like this is the dimension. just 1 gram of that material. So you can understand how fluffy the materials are, how low dense the material is. Okay, and this is something which is a kind of a representative image. I say even my 6-year son is a nanotechnologist. Do you know why? Do you know the reason why I prefer to call him as a nanotechnologist? Because he goes to school, he writes with a pencil, and every time you are marking the paper, you are basically exfoliating one layer of graphene or a few layer of graphene from the graphite that you are using. So am I wrong calling him as a nanotechnologist? Because he is also using the nanomaterial to mark the paper. Okay? So like this way you can see this is from a lead of a pencil. Like this is what it looks like, which is a 3-dimensional material. When you kind of go one layer down, when you land up with one single layer, the material is known as the graphene, and it is something even stronger than the steel. So it's a wonder material. Okay, and I have been doing this material for almost, let's say, last 15 years. I have been working on this particular material. The other attributes which you can get to see here is that when you take this graphene, which is electrically conductive in nature, the reason because it's an sp2 hybridized, lot of polyaromatic systems. So basically your electrons can hover around the material, okay? It's an electrically conductive material. But on the other side, if you look into the rubbers or the polymers, excluding a few polymers, majority of the rubbers are electrically insulative in nature. They do not have such kind of, mechanism through which it can conduct electricity. So, but we want to make electronic applications, and one of the prerequisite for making any rubbery material electronic is to put something electrically conductive into that, and then create an electrically conductive composite which can be used further for the electronic applications. Okay? With that, basically, I would like to go to the next part. So what we work is something like known as the flexible sensors or the stretchable sensors. Now rubbers, we all know it's a very stretchable material, right? I mean, let me see if I have a rubber band or not. Unfortunately, I'm not carrying, but if you see, it's one of the stretchable material, right? Because it does have this kind of very good capability to stretch itself. So what I thought is that nowadays if you look into the YouTube, what is the next gen sensors which are coming, or what is the next gen wearable material which is coming, people are kind of putting a patch like material on their hand and they are picking up a lot of vital information. Unfortunately in India not much research is done on that. I thought it's an empty space, let me penetrate in. Okay. But like I mentioned, like rubber is going to provide me the excellent stretchability, the bendability, twistability, whatever you need. Because if you look, human does have a curvilinear nature. It's not a straight, like, a lot of curves are there. But if you need to put those sensors and become a functional one so that it can pick up a lot of physiological information from you, it has to attach properly. Otherwise, it's not going to pick up those signals, or the vital information are going to be missed out. Okay? So what we did is that in that particular case, we mixed it with different functional nanomaterials. So one of the nanomaterials I talked about is graphene. It can be brother of graphene, brother or sister, whatever you feel like calling it, which is known as the carbon nanotubes, or any other electrically conductive material. So you can take this material, you can mix it, create a particular concentration of the fillers inside the rubbery material so that you land up in an electrically conductive point. Now the question is, how do you realize basically which material is behaving as an electrically conductive or not, at what point? So what happens is that when you keep on adding this electrically conductive fillers into the rubbery material or any polymer matrix, there is a concept called percolation network. What it does, basically you get to see here. So when you keep on adding that, you see a network structure is built into the matrix. So basically, in the initial phase, the fillers that you add over there inside the polymer matrix are by and large like remain discretely like dispersed into the system. But when you go beyond a critical concentration, this filler starts touching each other. And then when you keep on increasing, actually, this particular fillers will form a strong network structure. But if you see holistically, this is something, the point where the initial network structure, which I was referring to this one, it starts building. And this is something, if you measure the electrical conductivity versus the volume fraction of fillers, that means how much fillers you are adding into the system, this is the typical electrical conductivity curve that you get, okay? So initially it behaves as an insulative material, and next there is a steep rise in the electrical conductivity, and then there is a saturation which is typically observed over there, okay? More like taking classes of my student, because based on this understanding, the next story will be delivered to you people, okay? Now, the fact is, how do I make a sensor? Because this is something which has been known for ages. People have been mixing carbon blacks and other material and making this electrically conductive materials and electrically conductive polymers for different applications. But how does that matter in the world of sensors? So what happens is that this regime is very, like, I would say sentimental. बहुत sentimental है. Like, थोड़ा सा इसको disturb करो, like this network is something which is broken. And if this network is broken, immediately what you are going to get is a reflection in the electrical conductivity of this whole material. In other words, what you are going to see is that in an undisturbed condition, it is going to show an electrical resistance. But soon you disturbed, this network structure is completely devastated, and you get an increase in the electrical resistance. So that means you get a change in the resistance, or delta R factor. So this particular delta R by R0, which is the initial, electrical relative resistance, plays a very critical role in terms of controlling the behavior of the sensors that you are making, okay? Now, as you can see from here, this is very sensitive. Like, depending on the rubbers that you are taking, if you are showing this rubber with certain amount of particular temperature, there is a change in the electrical resistivity. If you stretch it also, indirectly what you are doing, you are also stretching this network structure. So apparently you are going to get a change in the electrical resistance there also. So then this dull rubber thing becomes very smart and intelligent. Like, you create a disturbance, you get an output. And that's what is the way of making rubberized sensors, okay? I hope it's clear. Now coming to the manufacturing or making of this material. So it can be done in a very simple way. We have developed certain materials, process using which, like, we can make these sensors even sitting at Scottish Church College. Like, let's say you have a t-shirt, like, I love Scottish Church College. The process by which these t-shirts are made is known as the screen printing or the stencil printing. Like, they have a screen, you have an ink, you dip it, and then you pull it actually, you squeeze it out, and you get an impression of whatever design you are doing. So anybody knowing, anyone from Maniktala can also make this sensor for sure. I can bet on that. But what you need to have is a good ink quality, because the flow of the ink quality is something which is very critical in controlling the wetting of the substrates that you are making. And then there is other techniques like compression molding. Compression molding is very simple, I'll tell you. It's like, घर में, बाड़ीते रोटी बनानो है, right? You make roti. What you do? You do like this, right? But take that dough and put a big thala on that and press it, what immediately you are going to get? You are going to get a flattened down thing, right? Of that particular shape that you are using. So in compression molding also, we utilize a similar concept wherein we have a mold, we provide certain temperatures so that the polymer can flow, and then we are also putting a lot of pressure on that, and you get whatever design you want to make. So this is a very simple technique, okay? So by and large, this compression molding technique and the printing technique is what my lab is basically working on making this fantastic rubbery material. Now coming to the sensors, some real examples. So what we targeted or kept in our basically to-do list is targeting the rural health of our country. Because if you see, government is doing a lot of activities in promoting, facilities to the urban, the rural people, providing the primary healthcare facility. But still, there are a lot of challenges exist over there. What we thought, if we can make some sensors which can pick up this vital information from your body and say that, boss, you are not doing good, you should go and visit a doctor, then nothing better than that, right? All of you know about sugar testing. How they do? You have a lancet, you prick, you have a kind of a meter, and then there is a white part which is known as the sensor. It pulls in the blood and you get a blood sugar level. But imagine if we can make something of similar which can say your lungs are not performing appropriately, or you are at a, you are prone to certain cardiovascular disease, like you are prone to stroke. Wouldn't that be, amazing thing? Just sitting at home in your mobile phone. India में कुछ ना है तो, but mobile सबके पास है, and internet connectivity is also there, right? So you can just sitting at home, you can get all these vital informations, right? And that's what in today's talk I'm going to talk about two specific disease, and it's a deadly disease which is which is kind of happening not only in India but globally. One is called the chronic obstructive pulmonary disorder. Like people with COPD, they face a lot of problems, like they cannot basically breathe in properly. They have certain kind of, problem in breathing. Always there is cough and all these kind of problems are there. And it is one of the most potential cause of mortality across the globe, okay? So what we did is that we made a sensor which can be embedded on a simple mask, like use and throw mask or a N95 mask, and just sitting at your home, you can get an idea, like, how is your lung condition is, whether it is working fine or not, okay? So with that, basically my student Simran, she is from Himachal Pradesh. I don't know why she came to Kharagpur in such hot condition, leaving, Manali, 5 degree to 45 degree actually. But she recently, completed her PhD and she did exceptional work actually. What she did is that she developed this smart mask, and which is like, capable of detecting your condition of your lungs. Let the video be played at the background. You can see like, the volunteer was wearing that mask. And here in the computer, these are all very smart material. I'm also smart, my lab is also smart. Like, everything is connected, right? So you can get all the output in your mobile phone, in your laptop, everything, okay? But what is important here, what we did is that we made a very simple technique, okay? We have taken liquid isoprene rubber. I hope polyisoprene structure or isoprene structure is clear to all. So it's basically a macromolecule. We have taken that. It doesn't have any solvent. And what we have taken the graphene, the wonder material in that, we mixed it and we have selected the sensitive zone that I was talking about using a technique known as this one. Like, it does have a rotation and revolution phase. And you get certain sensor formulation. Then what we did is that we utilized another very simple technique called the stencil printing. Like stencils, all we know, we used to write A, B, C, D like this, blah, blah, blah. Okay, so like that we cut out a stencil and we just printed it depending on the stability of the material, and then we printed this sensor. And then what we did is that we kind of put this sensor into the mask, and when you put this mask on and then breathe in, breathe out basically, what happens is that this sensor can effectively determine your breathing condition. Like this is something you can see, this is the breathing pattern. This is during the normal breathing, this is during the deep breathing, and this is during the slow breathing. Any abnormality in the breathing pattern will give you the first indication that your lungs is not performing well, okay? Secondly, we also calculated something which is known as the typical, the T in, T out. There are specific, if you look into the journals like Lancet or any other medical journals, basically, there are certain set values which are given. So a normal functioning lungs during the inhalation and exhalation time, there is a specific number associated with that. We tallied that, we consulted with the doctor, and what we found is that it is working absolutely nice. Now coming to the sensing mechanism, how does it sensing? Basically, when you are breathing in, breathing out, so the sensor is something which is moving little bit, okay? And this movement of the sensor is introducing certain strain, certain deformation into the sensor. And that's what is bringing into those signatures. So this is one of the development. The second development is something which is known as the cardiovascular disease, right? We love khashir mangsho with chorbi, right? So more you eat, more you develop this CVD, right? I personally love khashir mangsho, and I plan to take Golbari mutton tonight while visiting. I'm going back to. Okay. Get it out, or I have to heat it actually. I don't mind increasing my cholesterol level. I just got it tested and it is within the limits, so I can afford to go for a Golbari mangsho. So what happens is that there is certain plaque deposition through your arteries, and this arteries is something that brings in a kind of a restriction of the flow of blood through your arteries. And as a result of which, what you get, your arteries, or you are your heart needs to pump a lot for a proper blood circulation. So this is something which is also known as arteriosclerosis, okay? Or indirectly what you can say is that more you have this type of problem, you have this stiffening of the arteries. That means your artery become very stiff. It loses its flexibility, right? So what we made is a patch. It's a very smart patch. So he is Muthamil. Muthamil is from Tamil Nadu. He is about to complete his thesis. What do you get to see here? The patch, when attached into the wrist, like the radial artery, due to the flow of the blood, basically there is going to be certain strain induced into the system, and that strain is going to have an impact on the electrical resistance of the material, and as a result of which what you get to see, the human pulse can be very effectively determined. Like any abnormality is like, tell you that there is some problem. Not only that, we didn't stop there as well. What we did is that we predicted certain parameter known as the stiffness index, augmentation index, which are more of a medical terminology, like which tells your arteries are becoming very stiff. Okay, so it's time you should go and visit the doctor for proper checkup. Okay, so just by sitting at home, you can use this rubberized sensors and get an idea like how is your arteries behaving. Okay, and here also we utilized different fillers known as the carbon nanotubes, and the good part is that the sensors are not connected to your skin. It is on the reverse side, so there is no problem of nanomaterial contamination into your skin. Okay. Now we have been doing pretty good, honestly. Ever since we started, it was a very good start for us. We are doing pretty good in terms of the work, publishing in good journal. Couple of our works got highlighted in Nature also, that this type of works are done in India, as you can see. But the only problem with this material is that, these are not self-powered material. These are something which are known as the battery-powered material. You need a battery. Now, when you need this battery, the challenge comes is that the material loses its flexibility. The form factor becomes a kind of a bottleneck for that. So what we thought is that, let us do something and make some self-powered material. And with that, Aparna started working on a self-powered technology. What is a self-powered technology? Basically, here we introduce a concept of triboelectricity. Let the video be on in this particular case. As you see, there is a kind of a tapping which is going on. I don't know why it's, yeah. If you tap, you see those LED bulbs are going to brighten up, and you don't need to use any battery for charging this up. So what happens here, you have two layers material. One is known as the tribopositive and the other one is known as the tribonegative. So when this material comes in contact and they separate, there is certain electron hopping takes place between these different layers. And depending on the functional groups that you are having into the polymers and the opposite layers, this becomes more drastic. So this is known as the concept of the triboelectricity. So this material, what we did is that we have taken another isoprene based derivative, we modified with another natural material known as the tannic acid that you get in the tea actually. And by this way, we made a sensor, and this particular sensors are all self-powered material. Like, you know, you can get this, you know, energy harvesting done using this type of material. Okay? We not only this, for sports application and things like that, we made smart textiles also. Okay, we have taken cellulose-based textiles, okay, and we modified these materials with citric acid, and we have reduced graphene oxide over there. And in this particular way, what we made is a material known as vitrimers. That means even if you cut it, if you show a heat, it is going to heal by its own actually, and it does. It's a very effective material because you get to see in this particular case, this is also energy harvesting. All these you know, things are happening without any battery. You can charge up the material, and this sensors are something which are tactile sensor. Basically, if you are doing a body motion movement or anything, any muscle stiffness, you put on this cloth based sensor. Like I'm wearing a Tommy Hilfiger shirt now, but imagine this is having, like, you know, a smart textile embedded over here. It can at the same time predict my heart rate. Glad that it cannot do right now, otherwise it could, it could have shown that I'm a bit nervous actually. Okay, so like this way you can utilize this smart textile in the sports industry, and everything is possible using rubberized material. Okay. Coming to my, I think, the last slide actually, this is something we call it as a rag picker. Last summer I didn't have much work to do, only I traveled with Professor Naskar to Europe for certain days and then came back to heating India. Okay, what we did is that we collected all trash bottle from IIT Kharagpur. All water bottle, wherever we got. I asked one of my students, he came back with like a rag picker, like, sir, bottle lenechi. Okay, what we did is that we picked up those bottles and utilized it for energy harvesting. Okay, so it's a kind of a waste to wealth kind of technique. What you get to see is something, we taken this material and we have kind of introduced this triboelectric property, and what we did is something known as the smart locking system. So as you can see, here is a lock, okay, and these are a couple of pairs. Here in the console you can see, if you are putting a password, the lock is getting unlocked. Okay, similarly there are codes for myself also, right? But if somebody wants to breach into your security system, immediately what you are going to get is something, an email shootout that somebody tried to access this whole system. So into a smart locking also, this waste materials can be utilized. And this is something which is like a, freshly baked, I would say. I got this data early in the morning around 1 a.m. or maybe 12 a.m. Tonight. So this is something what we are also doing is something handwriting recognition. So we are taking this manual system using this particular locking. What you do, your encryption is basically absolutely locked through the signature that you are going to use over there. Why? If you see, if I sign A, so you get a different signature. If I sign, let's say I, you get a different signature. If I take Z, it gives you a different signature. So we are collecting all this data, training them using, AI and ML based technique, and creating a database. We have a lot of data on that. And using that, basically, you can use this rubberized material for this encryption of sophisticated material, where the unlocking, or it will not decrypt until and unless your signature is done. And why these peaks are coming? Because whenever you are writing anything, you are generating a corresponding voltage. And that's what is the machine learning is doing, basically collecting all this data and creating all the kind of variations that are possible for this encryption technology. But life is not so smooth every time. What used to be my case also, if I travel by Duso Punero, I used to reach by Howrah after 1 hour. If I used to take Ahiritola, 20 minutes. So you have to find out alternative strategies, like, you know, to win this race. You have to come up with the sustainability perspective also, try to include those sustainability things into the matrix, and you can get something very nice electronic products and very state-of-the-art electronic products using this rubbery material. And who can make it possible? People like you from the chemistry background or the chemical engineering background or the polymer engineering background, because without them, it will remain in a monomer stage. We cannot even polymerize it further and use it. Okay? So with that, thank you so much for your time and attention. I'm free to any questions. Yes, it is audible.
You may know about the flexible electronics. By we are doing what we are fabricating conductive inks by using inkjet printing process.
Yes.
Over substrates like plastic.
Absolutely.
I don't know about rubber, but that is what I want to ask you.
Right.
Is there any scope of fabricating conductive inks, mainly copper based, which are cheap and low temperature sintering can be processed? So is it possible to use copper based conductive inks over rubber substrates?
Yes, it is possible theoretically. But the only problem with copper, you are from chemistry, right? What it does form in presence of oxygen, air?
Copper oxides.
So that becomes a challenge.
We are trying to make any copper conductive inks with organic ligands, so that
Right.
can be sintered in low temperature, and the possibility of formation of copper oxide can be minimized.
Right. No, I think it's a good try. You can look into that. But again, another problem is that, you know, stability of ink is a big time. When you look into the inkjet printing and those kind of factors. I know one of my friend, Cynthia Casiraghi from University of Manchester, she does a lot of inkjet printing of this. But the discussion what I had with her is that, like, you know, when we are taking this metal-based nanoparticles, there is always, like, you can go for the silver also. So there is a chance that this material settle down over the period. So if you can achieve a good stability, and stability when I talk like 6 months, 1 year, like in that time frame, it's not that you make it and you print it and then it becomes a little tricky actually. But otherwise, it's a good strategy. If you can prevent the oxidation, you can have a good repeatability and robust data.
Thank you, sir.
I have two questions.
Yeah, please.
One is, have you thought of doing some work on EMI shielding using this technology?
Mr. Mithro, right?
Yes.
You are from Wacker. I'm a previous Momentive employee. And by the way, who doesn't know, Momentive was GE Silicones and their competitor. And when I was in Momentive, I commercialized a material for EMI shielding, which is a CIPG gasket. So intentionally, on a gentleman agreement, I didn't started anything on EMI shielding, but I know into the commercial formulations and.
So fantastic. That is the first question. Second question is, in these applications, have you ever thought of using silicon film?
Yes, it can be. It can be used actually. In fact, we are developing certain film-based technology not only to the silicons, but we are putting certain deposition on that and using it as a stretchable material, because silicon is, you have, without compromising the optical clarity also. That is something which we are also doing.
Thank you.
Thank you so much.
Good afternoon, sir.
Good afternoon.
A very interesting topic, my
Thank you so much.
Though I might not be anywhere near this topic, but I had read about graphene a bit. So I was thinking that you said that it has a sp2 hybridization, right? So it consists something like Dirac cones. So that has essentially zero band gap.
Right.
So I was thinking that if we introduce sp3 defects with
Absolutely.
covalent functionalization, how can that affect the sensitivity of the sensors?
So it depends actually. If you are looking for the electrical conductivity, what you said is perfect, absolutely correct. That's how we modulate like the band gap of the graphene. It's almost a zero band gap structure. So when you do any modification on the graphene, the sp2 hybridized system basically changes to a sp3 hybridized system, and apparently your band gap is kind of increased. So from a semi-metallic to a semi-conducting behavior, it does demonstrate. But that depends how much modification you are doing into the graphene. Because if you are doing too much of modification, there is a material known as graphene oxide, which is basically people take potassium permanganate, sulfuric acid, they create a khichdi and they put it, and you get a graphene oxide which completely destroys almost to 90% the electrical conductivity of the material. Okay, so that depends how much functionalization you are doing or what is the kind of change you are doing into this. So then also, even if it is a semi-conducting material, your basically what you call the electrical resistance will be still there, and you can have a kind of a sensor developed. That is point number one. Point number two, for the nano generators, which is a new concept I was talking about, in that particular case, you really don't need an electrical conductivity. In fact, electrical conductivity is detrimental for those self-powered material. What happens is that when you have a self-powered material, if you have those electrical conductivity point, there is a leakage current that is generated. So whenever the charge is generated, it is leaked out. So we do not need any electrical conductivity. But what we need is a modulation in the dielectric property of the material. And when you put this material, even if it does have a low electrical conductivity, it is pretty good in terms of the making the nano generator. Okay, so depending on what you are working on, an electrically resistive sensor or a nano generator, you have to select. Okay.
Sir, you mentioned the term electrical percolation theory in the graph for the conductivity versus conducting filler. Sir, what is this?
What is this? It's more like a samosa without aloo actually. You got my point? So if you have this fillers, what I said is that if you do not have this electrically conductive fillers into that, okay. So when you put this filler, let us explain, you are cooking something, right? So, or have you heard of bubble tea? Huh? Yeah, have you tried it? Okay, so you say a lot of bubbles are hovering around the tea, right? So in that particular case, what you can do is that when you put a lot of bubbles, actually at some point, these bubbles will touch each other and form a network structure over there, okay? And that's what is the percolation. That means you are putting the fillers into the polymers. Initially, it will be in a very delocalized state, like, you know, it will be randomly dispersed, okay? But when you keep on increasing, one point will come where this all particles will touch each other from one end to the other end. So that means if you are sourcing electron from one end, the other end, the electron is going to come out. So that is the percolation point. And beyond that level, actually, what happens is that it becomes extremely confined. The kind of fillers are, you know, all the connection possible are done already. So you don't get to see any further change in the electrical conductivity. So that percolation point where it initially starts bringing in the connections actually is the most sensitive point where you get this sensors like applications. Right. Right.
If you go on adding the filler component, you will get some dangling bonds.
Absolutely. Yep.
Those dangling bonds, if we apply external frequency or voltage, it will contribute to the conductivity.
Yeah, it is going to contribute to the conductivity, but not in the sensors, because what we need is that for the sensors, no, not maybe, this is proved, it's like when you have this particular, this percolation regime, what it does is that, perhaps you might have missed that point when I was telling, when you are putting any stimuli, let it be temperature or pressure or strain, whatever be the case, this network structure is disrupted. So all the connections are broken.
So already you are above the percolation or?
No, at the percolation.
At the percolation.
At the percolation.
Just at PC.
Yes, and that is where is most sensitive part. And you get a lot of resistance change when you have, like, any kind of external stimuli acting on the material. So that is something important for the sensors.
That TNG part, you showed the some
Right.
variation of current or power density as a function of resistance.
Absolutely.
So that corresponds to TNG part?
Yes, that corresponds to the TNG part, because we need to match the resistance at which resistance it is showing the highest power density.
Yes.
I intentionally skipped that physics part because more of a chemistry oriented I wanted to talk. So power density is something, how much power it can generate that material. So typically we have an oscilloscope, and using that oscilloscope we get the
No,
data.
You have also mentioned the current in the y-axis.
Absolutely.
in that graph.
Yes.
So what is the significance of that?
So how much current it is generating? Because one of the primary problem with this triboelectric nanogenerator is that insufficient charge, insufficient current in that. So if you can increase these 2 points, then you have a very nice kind of a triboelectric self-powered material. Otherwise it is not going to have a constant source into the material. Like, it is going to blink, but it is going to fluctuate. So that is something, one of the unmet need in the kind of a triboelectric nanogenerator market.
Yeah, excellent piece of work.
Thank you so much.
Yeah, so I was curious to know about that. What type of graphene you use, because you know that the functionality is very detrimental towards the electrical conductivity, which is very essential for your applications. So what you made at your lab, or you just procured from?
We procure wherever we get.
So
we procure.
it is like a pristine graphene, or is it graphene nanoplatelets, or?
So, being a graphene technologist for the last 15 years, I could say is that they will say it's a graphene first of all, but that's not graphene. They mix it with graphite.
Yeah, it's a
So
kind of
it's not nanoplatelets. Okay. So it's basically, it does have a few nanoplatelets which will easily exfoliate when you put it into the polymer or whichever solution, but it does have majority three-dimensional graphitic material, and graphite is also electrically conductive,
Yes.
and it is solving our purpose.
And now you didn't do any kind of functionalizations
I did it for 8 years. I was bored because
in this particular work, like
no, we didn't, because scaling up would be a bit
understand.
challenging. So that's why we opted for off-the-shelf material, and we went ahead.
And
with
now,
that.
what is the typical filler content in that loading content? Like that is also very important actually.
Absolutely. Here, I think it was, if I look into the volume fraction, like phi equals to 1 means completely filled system. If I go for like phi equals to 0.2 to 0.3, in fact, in some of the cases, this one,
as it is high surface area, so obviously lower loading content will be.
I will tell you, this was like, as far as I can remember, this phi was something around 0.05 or 0
Is weight percent of volume?
volume fraction.
Volume fraction.
0.05 or 0.02. As far, but I can get back to you by seeing the paper.
Actually, the compatibility is very important while you mix in matrix. Because
Absolutely.
So, is it compatible, or you have to add some surfactant or formulation, something like that?
In this particular way, what we do is that we modify, we play with the rheology. You are absolutely correct that there are a lot of agents which can be added to have a good compatibility
But it will
between.
affect also the electric conductivity.
Absolutely, because surfactant, it used to be, when I was in Houston, in Rice University, people were adding a lot of surfactant, but it does have a detrimental effect on the electrical conductivity. So, as far as you can keep the system clean, less component, it becomes easy for manufacturing.
And then what kind of, you have shown that substrate, like what substrate it was?
So, in the sensor work, we have used PET, normal PET, like we used to use for overhead projection, right?
The normal low temperature one.
We used PET.
And that mechanism is simply based on the like the sensing mechanism is simply based on the changes in the
Yeah,
resistance, correct?
it changes in the resistance. So that's why we call it as a resistive type of sensor.
Yeah, it's a resistive sensor.
Right.
So instead of graphene,
Huh.
one can use like metal nanoparticles or silver
Absolutely.
nanoparticle along with the graphene. It might have. So, what is your thought? Like if you use a silver graphene
Silver
nanoparticles-
again, I have some restriction.
Okay.
I have some restriction in the sense because first of all, silver adds up to the cost. Okay, and second is that settling down phenomena. We have seen during my company days in G Silicon. So that's a problem. It settles over the period of time.
And it was a very nice piece of work, but actually I am till now stucking at that Khashir Bangsho and that. And what I think this is the Bengali motion that we are stucking at that, but actually I am very much happy with that COPD portion, because we know that nowadays that COPD or asthma becomes like equal to the cancer. Okay, but and I wish that after few days we can able to see something, some nanomaterials that could able to fix up that lungs that is not working properly. So all the ways to Dr. Mondol. Now we will move towards our next speaker, Mr. Komulesh Jain. Mr. Jain is a managing director of Holdwell Components Private Limited. So please give me a chance to give a brief introduction of you. Mr. Jain completed his graduation degree in commerce from Calcutta University and MBA from a prestigious Indian Institute of Management, Kolkata, IIM, Calcutta. As the managing director of Holdwell Components Private Limited and Royal Elastomers Private Limited and director of Royal Frestiners Private Limited, he oversees operations that cater to critical industries with products like high-speed railway components, advanced technical rubber, conveyor belts, safety items, and so on. He also holds the position of President of West Bengal MSME Startup Forum Bharat. A strategist at heart and a mentor by choice, Mr. Jain continues to be a guiding light for the emerging professionals, entrepreneurs, and organizations striving for excellence, innovation, and inclusive growth. We welcome Mr. Jain for the next talk, and now today he will discuss about a very interesting topic, the fitness, new emerging business opportunity. Welcome, sir.
So this is the next very big thing which is happening in our country. How many of you have heard about the decathlon? Oh, I see somebody. Can you please stand up? Gentleman in the green. Yeah. Please stand up. Yeah, don't worry. It will be an interactive session. Without your support, my talk will not work out. So decathlon is which country it belongs to? Any idea? No problem. Yeah, tell me. France, lovely. So we are here to talk about business. I am from industry. I understand the language of money, nothing else. So how many of you want to make money? Raise your hand. Oh, first time I am seeing. Interesting. Good. So you are in the department to understand the application of your knowledge into making money. Right? I put it in this way. So Dr. Pitash Mandal has explained how new vendor materials are coming, which is helping us in making advanced technologies which we can use. So I will take you all through quickly I will take you through the presentation on what the fitness industry looks like and how we can become a part of that. So what is the growth of the wellness market in the last 4 years? Let's have the data. So can you just stop this? So let me introduce you to this lady. I met her, I went to Mumbai. There was a global leadership summit She is the brand ambassador of International Hindustan Liver Limited. So they have a different perspective. Our vice principal was telling about the outlook and perspective. So I wanted to get the perspective of what are the thought leaders thinking on various subjects. And they are focusing on wellness market. So she has a take on wellness market. I would like you to look at this clip and understand how things are happening. So the sound is not audible, so I'll show you the data. So she is telling how the market from 4.6 trillion is going to increase to 7.5 trillion in next 5 years in the fitness market. Because now what is happening is you are spending more time on the table, using more screen, so your physical fitness requires to balance, and if you are not looking at that, so you will have lot of kinds of physical and mental issues if you are spending more time on the screen. And if you go to people with advisories, they will tell you spend less time. After 15 minutes you go for a walk, you do some exercise to the mind sink in with your body and mind. So here is the data she has shared. Global health and wellness market. Now you will say what I have to do with the wellness market. So we will show you some idea. This is few items which are made from rubber. This is, can you go back? Yeah, this is a mat, yoga mat. This is made of rubber TPE, thermoplastic elastomer. How many of you have heard about this? Are you aware? So this rubber is used. Then we have resistance band. This is again made of natural rubber and TPE. And this does not require weight lifting. These are the new ways of doing exercise. You have a portable gym at home. So the person who has gone to Decathlon or who are aware of these things, they know these items are available over there. So how they are used, you can have a look at it. So instead of weightlifting, you can go to 25 kgs, different strength of bands are there, which you can use. So this is used in prehab, rehab and progressive overload. Next. So foam mats I have told, foam again falls into a rubber category. TPE is there, other types of foams are there. So that can be converted into different kinds of product. So here is the complete type of item: balance training equipments, hand therapy, show. Now when you come to balance training equipment, you have got lot of next age people coming up who will be aging. They require a lot of support. How many of you have heard about physiotherapy? So physiotherapy are of two types. One is once you are injured, then you have physiotherapy to recover. The other is at the senior aging time, you need to have support to see that you keep on adding strength to yourself, muscle to yourself. So you need to have. So if you look around yourself, lot of people have ventured into this. They have taken training. You don't require any specialized kind of thing, but equipment supports are there. So what is the advantage? Grip and durability, floor protection, cardio and endurance. These are all rubber coated items. So this is another application. So even Government of India has understood that there is a lot of initiative required in the playing sector. So they have initiated Khelo India, a sports culture. So if you try to talk to friends who are overseas, you will come to know they are spending a lot of time on sports and physical fitness and all, which culture is still lacking over here. So we need to really look into that and ensure that some physical activity, some sports activity has to be part of our life, which will improve our well-being. So this is the graph they are showing how the trend is rising. You are saying that at Olympics and other areas, how our sports heroes and rock stars are becoming because they are giving all kinds of facility and they are earning more than an industrialist. So Decathlon we talked about, a startup we started. Now they have a value chain, supply chain where they are sourcing from India. They want to make it completely, earlier they were importing from France, and now they are indigenizing. And they try to open 195 stores. So these are all the areas, new areas where you can look into. So new business opportunities. Now we will talk about the advanced technology which I believe Dr. Pitesh Mandal has already touched. That how many of you have heard about the patch which monitors your blood pressure? And so there are so many electronic items which are registering your medical conditions and giving you real time connected to your watch, smart watches or smart mobile. So these are the new advancements taking place, so there are enough opportunities over here. So Oil and Tech is specializing health and sports. And it is, the market is set to exceed 70 billion. CGR 21.38%. And predictive analysis. Now I am hearing people are saying if this testing is done, they can predict this guy is going to have cancer, this guy is going to have this cancer, this guy is going to have a heart attack, this guy is going to have pulmonary disease. So all this is happening with the AI. So I believe these are the areas where if you are clubbing with the academia like IIT and all and work on some projects, and you will have very good opportunities over here. Faster diagnosis, remote monitoring. So the rubber fitness market is poised to grow, driven by increasing demand and evolving fitness. And we are into, already briefed, we are into railway track engineering. The bullet train, first bullet train which is coming up, we are part of that project. We are trying to make some good components for that. We are into rubber sealing solutions also and advanced rubber technical products. That's all. I did not want to carry much time because you are all awaiting eagerly for the lunch. If there is any question answer, please ask without hesitation. If you have to progress, you should have a mentor. You will always remain confused if you don't have a mentor. That's a common problem nowadays. So you should have a very good mentor. You have your teachers, you have your professors, you have your principal, you have your family members. We are there. The other members are there. You can talk to them. If you are confused what stream to take, where do you want to go, they can probably give you ideas and you can probably explore the possibilities. Thank you.
Any questions, students? Any question? I guess they could able to understand all these things and they will follow all these things in their life, right? You are going to follow this? Okay, thank you so much, sir.
Thank you, sir.
Okay, now we will move towards our last speaker before the lunch session. So I would like to invite Dr. Upendranath Nondi, Barsar Scottish Church College, and before that, it's my proud privilege to give a brief introduction about him. Dr. Nondi holds his graduate and postgraduate degree both from University of Calcutta, followed by his PhD for SINP Kolkata in the field of electrical transport in non-linear inhomogeneous systems. He joined Scottish Church College on 2001 and has been teaching here till now. His efforts and dedication has been marked by the research and development that has been done within the limited faculty. With publication in reputed journals and books, those has been popular in the relevant field, Dr. Nondi stands out as a motivation in his institution. His contribution to the academics has been honored by Indian National Science Academy Teachers Award 2021. He has been a fellow of West Bengal Academy of Science and Technology at the same year. We are delighted to have Dr. Nondi among us.
Very good afternoon, everybody. So, now we are fit because we have gone through a room consisting of several instruments. We have used that gymnasium. I think we spent another half an hour on a topic in which we will be dealing with the energy storage systems. The electrochemical impedance spectroscopy, an efficient probe for energy storage systems. I have organized the presentation in this way. First we will put an introduction to it. Then I will try to focus on how the electrochemical properties of energy storage systems is analyzed. So we will say there are 4 different processes by which we can extract the electrochemical properties of energy storage systems. Out of that I will focus on only one, the electrochemical impedance spectroscopy. This one, the electrochemical impedance spectroscopy. Then we will focus on that, how this EIS is measured and what are the advantages of it. If once getting those EIS data, how to present those data using the Nyquist and Bode plots, then we will switch over again to the energy storage systems, because you know our objective is to extract out the power density, the energy density of an energy storage systems, and those electrical parameters are mapped to electrical circuits, and those circuits are involved with certain parameters, and those parameters will ultimately focus on the electrochemical properties of energy storage systems. Before going into the details, what are the different types of circuits are used to analyze the electrochemical properties of energy storage systems, I will discuss some simple circuits and their corresponding Nyquist plots. Objective of these simple circuits are, once you know how to choose to model the energy storage systems, the proper choice of circuits, corresponding parameters, then only we will be able to predict the correct values of energy storage, energy density, power density of those systems. The circuits used in literature are generally termed as the Nyquist circuit. Then the corresponding parameters involved there and their physical role. The sole point of this half an hour presentation is, for the EIS measurement, we use certain instruments, inbuilt instruments. With those instruments, you will find some softwares involved. When you will load the sample for the measurement of EIS spectroscopy, there is a software to map those EIS data. Those softwares will give you certain data available. You use those data to calculate the power density and energy density. I will focus on that. The techniques used with the software available with those instruments are not correct. Then what will be the Solution, we'll discuss this as problems associated with the interpretation of AIS data in literature, then a possible solution to this, and related differences and collaboration, and finally the conclusion. Okay, as an introduction, already we are discussing with the energy, the world in which we live, we need energy. Energy initially we got in the form of fossil fuels, the oil, natural gas, the petroleum oil, but you know their storage is finite. Though their energy density and power density is very high, but that storage is finite. Shortly we will be running out of that. What is the solution? The world is witnessing a transformative shift towards renewable energy sources like solar, wind, hydroelectric power. But you know, these are the cost effective and clean, abundant way to meet the growing energy needs. But they are intermittent. Their energy density is low. They cannot satisfy our needs. Then what is the solution? The material scientists and the condensed matter physicists have turned up their attention to different types of energy storage systems. The systems must satisfy two criteria. One, they must be environmental friendly, eco-friendly. Number two, their energy density, power density should be very high. That is the objective. So those energy storage systems, what are the different types of energy storage systems? Generally we talk about these types. So one, the mechanical storage, the thermal storage. I won't go into the details of this. The electrochemical storage. We are talking about this. The electrochemical storage. Batteries, supercapacitors. Battery, we know the chemical reactions takes place inside those cells having two electrodes giving you some potential difference. You use it for further pressure. Supercapacitor. Those are the things now it is being focused by the recent researchers. So if I want to focus on the electrochemical properties of energy storage systems, we want to extract this property of a given material, maybe a mud material, maybe a perovskite material, maybe a multi-wall carbon nanotube cellulose. We want to focus out how much energy density these materials possess. So we have to carry out the measurements. What are the different types of measurements? The measurements we generally carry forward are the cyclic voltammetry, galvanic static charge discharge, linear sweep voltammetry, electrochemical impedance spectroscopy. Those are the four types of measurement generally carried out to extract out the energy density of some energy storage materials. But in this presentation, I will focus on the electrochemical impedance spectroscopy. Only this one. Not this one, but only the electrochemical impedance spectroscopy to find out the energy storage capacity of these types of systems. Now you see, this plot is known as the Ragone plot. If you look towards this, the specific power is plotted as a function of specific energy. This is a log plot. You can see the region belongs to the supercapacitor. It is a unique and broad region within the energy storage spectrum, striking a balance between high specific power and moderate specific energy. This position indicates that these materials having this type of supercapacity behavior possess can be used as a good ideal candidates for the energy storage with long cycling capability. Okay? Now, since out of these 4 different types of measurements, we will be looking for to extract out the energy density of such systems. I will be focusing on the electrochemical impedance spectroscopy. So next question generally arises, what is electrochemical impedance spectroscopy? What is the basic measurement technique of EIS? What are the advantages of EIS? How are EIS data presented? The Nyquist plot and Bode plot. So my dear students, think this is your material. We want to find out its power density, energy density. There are 4 types of measurements: cyclic voltammetry, JCB, USB, and EIS. I am going to focus on EIS only. Yes? What is EIS? I will now tell you. What is EIS? What are the basic requirements? And how to, yes, electrochemical impedance spectroscopy is a very useful technique for the characterization of electrochemical characterization of energy storage materials. It offers kinetic and mechanistic data of various electrochemical systems and is widely used in commercial studies, semiconductor science, energy conversion and storage technologies, chemical sensing, biosensing, non-invasive diagnostics, etc. Measurement technique. You can see here, it's a 3-electrode system. 3-electrode system. Generally, if we want to measure the current voltage characteristics of a system, we say the constant current, measure the corresponding voltage. But we say here, we use 3 electrodes for the measurement. My dear students, if you are interested in this particular field of research, ask yourself what is the use of 3 electrodes. 3 electrodes, it's very important. Why we use 3 electrodes? For the measurement of EIS spectroscopy. So here you see, we have the counter electrode. Generally, using the counter electrode, we measure the current, and this is the working electrode. The material for which we are going to investigate the power density, energy density, or electrochemical properties. This is the working electrode. And this one is the reference electrode. The reference electrode is used. You know, there will be several types of reactions will be taking place. I will come to that after 2 or 3 slides. What are the different electrical parameters can be assigned to such electrolyte, electrode interface, the electrolyte itself, and the corresponding Faradic, non-Faradic reactions taking place at the interface. We have to represent all those physical facts occurring inside that event with the help of the electrical parameters. That is the objective. Then we will be able to predict the correct values of power density and energy density. That is the objective. Okay? So this is the 3-electrode system. When chemical reactions takes place, in order to generate the potential difference inside the systems, the potential changes. If you go on measuring this, there will be an error. Therefore, we use a reference electrode. A reference electrode, and this is the working electrode, and the counter electrode used to measure the current through that. Okay? Then what is the advantage of this EIS spectroscopy? It's a first one, non-destructive technique. The sample will not be disturbed, will not be destroyed. Very important. It is a linear response, means add a small perturbation to the system, it will not be driven to the non-linear regime,
it will be in the linearism. So there will be minimal disturbance created inside the system so that its intrinsic properties will not be changed. This is a very good disadvantage of this EIS spectroscopy. Then EIS can be quick testing, means very short time we can measure it. It is a steady state technique. At the same time, if we use to increase the power density of the system, the several components, each and every component inside the electrolyte will be characterized by their own characteristics time, CR, the time constants. So each and every component will have their own reaction times. Some are slow, some of them are very fast. So in order to characterize them, we'll be having different time constants corresponding to the different elements in the electrical equivalent circuit. This is very important. We'll come to this point later. So this is a very advantageous technique for measuring the electrochemical properties of systems. So we measure the EIS spectroscopy. We get certain data. So how to present that data? It will be, I stop. It will be somewhat difficult to the chemistry students. Okay, so I will be very slow in presenting this. Very slow in presenting this. What is that? Suppose we have a circuit. The circuit consists of a resistor, a capacitor, and inductor. Altogether, they are termed as impedance. Agree? Yes or no? Impedance will have real part, imaginary part. No doubt. Impedance will have real part, imaginary part. Okay? Plot those imaginary part along y-axis, the real part along x-axis. We get certain behavior. Think of that. We have an electrical circuit consisting of elements giving you the impedance, total impedance. The impedance has its real and imaginary parts both. We have plotted imaginary part along y-axis, real part along x-axis. Then we get different points. Why we will get different points? Because the impedance is a function of the frequency. These points corresponds to different frequencies. This is known as Nyquist plot. So what is Nyquist plot? Nyquist plot is the plot of imaginary versus real parts of the impedance at different frequencies. Clear? If we don't understand this, rest of the part will be big zero. Very simple. We have a circuit, calculated its real part, calculated its imaginary part along y-axis, real part along x-axis. At each and every frequency, we will get certain points. Those points are plotted here, giving you the Nyquist plot. I am not discussing this Bode plot. They will be having some phase, magnitude of impedance. As a function of frequency, they will be changing. So those changes are plotted. You see, this is a log-log and this is a semi-log plot. So you will get these two plots together are known as the Bode plots. I will not discuss the Bode plots. So EIS spectroscopy, Nyquist plot, electrical circuit, then energy density. Finally, I will come to that energy density of the systems. That is my objective. How to find out the energy density and corresponding power of the exhibited by the system. To find out those two parameters is my ultimate aim. Mind it, but the route is this. Next, extraction of electrical parameters characterizing electrochemical properties using Nyquist plots. This is the real electrode system. We have our own system as the working electrode. This is the working electrode, the reference electrode, the counter electrode, electrolyte is here. So we want to model the EIS data, explain the EIS data using an electrical equivalent model. So what are the corresponding parameters in terms of the electrical properties are there, we have to identify. So first you see the solution resistance, the resistance of the electrolyte. You know, some electrolyte is there through which ion migrates from through the electrode towards the interface between electrolyte and electrode. So they will suffer certain resistance. This is known as the solution resistance. Then there will be some charge transfer mechanism at the interface between electrolyte and electrode. So that is RCT. Double layer capacitance, charge separations will be there, forming a double layer, and those will behave as a capacitor, and its capacitance is CDL. Sometimes you will find that diffusion is a process which arises in such systems due to the difference in concentration gradient. So diffusion is not taken into account by this resistance of the electrolyte or the charge transfer resistance. So in order to account for that, the mass transport, the charge transport, okay, through the process of diffusion, we have to take into account an electrical parameter known as the Warburg impedance. Warburg impedance. The Warburg impedance will give us certain coefficient, Warburg coefficient. Those coefficients will also provide certain values. How to find out those? I will come to that point. Then constant phase element. You know, if we have a simple RC circuit, the current in that circuit will lag by 90 degree, pi by 2 to the voltage, if the capacitor is an ideal one. For an ideal capacitor, there will be a pi by 2 phase lagging. But in case of such electrode systems, the behavior is not ideal because so many factors work. Therefore, we have to add a constant phase element. So these are the different electrical parameters to model an electrolyte systems. And then in order to introduce the Ranelagh circuit, we have to discuss some simple circuit giving you the concepts of Nyquist plot. How? Say consider this simple R and C connected in parallel. Is it known to you? I think you know this combination R and C. Yes or no? R and C. Okay. So this will provide an impedance. Product of these two, C will have reactance 1 by j omega C. So R into 1 by j omega C divided by R plus 1 by j omega C. Simplify it, separate it into real and imaginary parts. So this is the real part and this is the imaginary part. ZR and ZI. Where ZR is this and ZI equal to this. Now from these two expressions, eliminate omega. You will get an equation of a circle. Very simple. Eliminate omega from these two equations, you will get an equation of a circle. This is the semicircle. This is the semicircle. Why I am telling this? Suppose we have the electrolyte system. Electrode is there, interface is there. At the interface we have the capacitor. The electrolyte will have certain resistance. They are connected in parallel. So that observation can be replaced by this one. Very simple. That observation can be replaced by this one. So from these two, using Nyquist plots, we will get a semicircle behavior. What is this end? What is this end? This is the f tends to 0. Why? Low frequency means this will be very, very high. The reactance offered by the capacitor will be very high, so we will get only this one. So RC. And high frequency region, this one, high frequency, it will behave as a short circuit, so total impedance will be 0. So this is the high frequency part, this is the low frequency part. So from the low frequency measurement, we will get the resistance of the electrolyte. Very simple electrical equivalent circuit, we will get the resistance of the electrolyte. So if we have two such circuits, say, you see two R1 C1, R2 C2. What is the meaning of it? The meaning of this same two circuits is, in the electrolyte, two different components may be present there, taking part in the redox reaction at the interface between electrolyte and electrode. So those two components will have their own time constants representing the rate of reaction. So just you see, at the highest point, at a corresponding to a given frequency, where the real and imaginary parts are equal, here we will get one time constant, another time constant. So just observing the Nyquist plots, which reaction is slow and how much resistance is offered by that particular reaction, which reaction is fast, how much resistance is offered by that particular reactions, can be inferred from this particular and simple Nyquist plots. So objective is very simple. If they are equal, again we get back the semicircular behavior. Okay? Now you see another inclusion. Here RC, one resistance of the electrolyte itself. Here the resistance of the charge transfer resistance, capacitance of the double layer, and this is the resistance of the electrolyte. Again, calculate its impedance, find its real part, find its imaginary part, eliminate omega, you will get an equation of a circle. What is the meaning of this? You will get two different, I have plotted this in this because Zi is negative here, Zi negative. So here we have plotted in this fourth quadrant. So from this we will get one parameter, from this point we will get another parameter. So what are the things? We will get the information about the electrical properties of the electrolyte, the capacitive property at the interface, the resistive property of the charge transfer taking place at the redox reaction. Because all these are altogether contribute to the power density and the energy density. Okay. I skip some part. So after discussing this simple electrical circuit to represent the electrical properties of an energy storage system, the history goes in a different way. The man Ranelagh first introduced the representation of electrochemical properties in terms of electrical parameters. So the idea I have discussed using the simple circuits. Now will be clear when we will discuss the runless circuit. So what is runless circuit? You see, this is the runless circuit. RS, the resistance of the electrolyte, the capacitors of the double layer, and the charge transfer resistance. Here we have introduced one term, ZW. It was not earlier present in the circuit diagram. Now you see ZW, Warburg impedance. Why it is it arises? Because of the diffusion process. Diffusions of ions from the electrolyte to the electrode or interface of the electrode. Okay? So that is given by this. This W is known as Warburg coefficient. Warburg coefficient. So this is the charge transfer resistance, and you can see it here, the reaction taking place. So first Runless introduced this circuit to model electrically the electrolyte system. And now what will be our scheme? Tell me, what will be our scheme? For this circuit we will calculate Z, then real part, then imaginary part. We will plot it to get the Nyquist plot, and from that Nyquist plot we will try to find out the parameters. That is the objective. That is the objective. Okay? So this is the total impedance of the circuit. Now it becomes very hard to understand, right? Circuit only 3 components. I will show you some circuits we have dealt with. Okay? So this is the real part, this is the imaginary part, and the corresponding plots you see, the Nyquist plots. It has changed its behavior. No more half circle. No more half circle. At lower frequency, we get a line. We get a line. So if you do get such behavior from the EIS spectroscopy, select the suitable runless circuit, calculate Z, Z prime, Z double prime, plot this type of diagram and find the corresponding parameter. Then we will get the correct value of power density and energy density. So these are the different circuits I have handled, or rather we have handled. My PhD students are sitting here. This paper we have communicated to Journal of Applied Physics. 56 pages paper. Only one information. Only one information. Now we'll stress on that information. What is that? You see, generally with the instruments measuring for EIS data, these softwares come: ZView, ECLab from Biologic, Nova, Metro, Motolab, Zman, IBM Soft. These are inbuilt. Provide them the data, they will fit it, and will provide the values of RS, RCT, CDL, etc. Now you see, hello, the nature of fitting. The nature of fitting you see. This is the circuit diagram. This was the author's fitting for a sample, Zhao et al. The sample is Bi2S3, MOS2, and they are composites with different percentage. You can see the fitting. We got this from the data from literature. Now we use the same circuit, manually calculated Z prime, Z double prime. Then at different frequencies we fitted those data. You see the red one, our fitting. the red one. For this type of sample, you see, the author fitted in this way, and our fit is this. For this sample, we have included the fitting parameters. So don't rely on the software supplied with the instruments for extracting out the electrical parameters for the characterization of electrochemical systems. That is one point agenda. Very simple one point agenda. Okay? So, one or two slides. Another fitting is this. This is our data. Gadolinium doped MOS2. This has been published in 2024 in Journal of Energy Storage. And then another one, ruthenium doped MOS2. This has been published again in Journal of Energy Storage in 2025. Okay? And you can see the fitting and corresponding electrical circuits. And these are some of the recent references from our lab at Scottish Church College. I feel myself very lucky. I have got a space here to install certain instruments and doing some research, having some PhD students and some collaboration. You can see the collaboration here. These are my major research projects. This one, recently I have completed this one, CRG project. And these are my collaborators, Professor Osni Ghosh from ICS, Professor Pradeep K. Majhi from Roorkee IIT, Dr. Mukul Pradhan from Warangal National Institute of Technology, and finally, thank you. So if you have any questions. In those papers.
Thank you, sir. Thanks for adding the physics touch in this chemical seminar. And we, the dumb chemist, could also able to understand all this physics thanks to his lucid presentation.
Good afternoon. This is my special privilege to read out the message sent by the Honorable Minister. She regrets that she could not make it to our college, but it is we are indebted to her. She's busy in cabinet meeting. But I think this is our, it's a great honor she has done us by sending us a message, and we are privileged to be reading it. It gives me immense pleasure to be a part of the seminar and poster competition titled An Academia Industry Outlook, jointly organized by Scottish Church College and the Indian Rubber Materials Research Institute, Government of India. In today's rapidly evolving world, the collaboration between academia and industry is not just valuable, it is essential. The theme, Materials Today in Perspective of Sustainability, is both timely and urgent, reflecting our shared responsibility towards creating a greener, more resilient future. Materials science plays a pivotal role in addressing global challenges, from reducing environmental impact to innovating sustainable alternatives in manufacturing and infrastructure. I commend the Department of Chemistry, IIC, IQAC, and R&D cell of Scottish Church College for spearheading this initiative and creating a platform that encourages young minds and experienced professionals to exchange knowledge, share research, and build meaningful partnerships. Let us continue to nurture innovation, foster inclusivity in science, and bridge the gap between educational institutions and industry. May this event inspire new ideas, partnerships, and a shared commitment to sustainability and excellence. My best wishes for the success of the seminar and heartfelt congratulations to all participants. Dr. Shashi Pandya.
A panel discussion on the students' role in the need of modern industry is to be deliberated among eminent industrialists and academic stalwarts. This deliberation and discussion is between a very pragmatic theme, and among our delegates. So, to chair the session, to moderate the session, I would like to request Mr. Navratan Jha to please come to the stage. Let me just give a brief introduction of you, sir. Mr. Navratan Jhawar is the Managing Director of the Suncrest Industries at Boj. He started the second unit of the factory at Dankuni. It can be called a sister concern of Rubbertech. By taking over Suncrest, Mr. Jhawar extended its footprint in the rubber industry. In 2008, he moved the business dimension towards the real estate. In the year 2008, he started Suncrest Realtors. Apart from that, he also running a homeopathic medicine factory at Rajarhat. So please, sir, he will moderate this panel discussion session.
Yeah, good afternoon everyone, and I hope everyone have taken their lunch properly. So now we are on behalf of joint organizer Indian Rubber Materials IMRI and Government of India Institute. I welcome all distinguished guests from academia and industry and beloved students in this pragmatic topic of panel discussion. The theme of the panel discussion is students, the role in the need of modern industry. All of us here and there know it very well that students are the pillar of the civilized society and the state. Role of them plays crucial roles in development of any country in a bigger way. No industry can flourish in terms of operation, production, automation, R&D, quality control activities without fruitful and dynamic contribution of hired pupils from academia. Today, government is implementing policies which are industry friendly for academic institutes to adopt the design, the syllabus accordingly so that industry can get skilled, efficient and enthusiastic manpower for their daily affairs. Industry, basically rubber industry in both domestic and global sales, it is standing across a robust threshold of self-reliance and exponential growth in respect to global competitiveness. In recent time, India is exporting a huge amount of rubber product to the rest of the world, courtesy to quality improvement and consistency. Contributed by young resources and at R&D, Indian tire industries for last 4 decades have contiguously occupied top 10 position in the world due to their cutting edge R&D work in alignment of global demand and adaptability with respect to sustainable development and circular economy. So the string attached between students contributing highly towards industry growth and industry demand is extremely strong and sustainable. Today we had gathered here in this very prestigious and high legacy college, Scottish Church College, to have deliberations and discussions amongst eminent industrialists, renowned academicians and government officers on the practical issue. So students, really you are the future of this country. Particular rubber industry is also needed very good future in India. Since Dr. Rajkumar told that there is a huge acceleration of the rubber industry in India. So I giving you the advance best wishes for your future academic. So now we are going to start the our discussion. So in panel, I am inviting first Dr. Rajkumar, Professor Kinshuk Naskar, Professor Abhijit Bhattacharya, Bandyopadhyay, Abhijit Bandyopadhyay, Mr. Kamlesh Jain, I think Kamlesh Jain is not here, so, and Mr. Kamal Chaudhary, Mr. Sandeep Mitra. He was the chairman BIS PCD 29, member BIS PCD 13, ISO TC 45, BIS TED 7, BIS ME 17, BIS PCD 28, etc. So welcome you, sir. Also Professor Kinshuk Naskar was an alumni of chemistry department of this same Scottish Church College.
He received his Bachelor of Technology degree in Polymer Science and Technology in 1998 from the University of Calcutta. In early 2000, he completed his M.Tech in Rubber Technology from Indian Institute of Technology, Kharagpur, silver medalist. He pursued his PhD during 2000 to 2004 from the University of Twente in Kede, Netherlands. Currently, he is holding the position of a full professor and head of the Rubber Technology Center, IIT Kharagpur. Thank you, sir. Welcome. Kharagpur University. On 2004, Mr. Mitra joined as process chemist executive at Walker Metro Arc Chemicals, an Indo-German joint venture company for the production and sales of silicon materials for the Indian subcontinent and export business. He made a significant impact at Walker on developing new silicon micro and nanoparticle emulsions and specialty polymer for various applications. Welcome, sir. Dr. Abhijit Bandyopadhyay is currently a full professor in the Department of Polymer Science and Technology at University of Calcutta and Technical Director of South Asia Rubber and Polymer Park, West Bengal. He is National Scholar, has received Young Scientist Award in 2005 from Material Research Society of India and Career Award for Young Teachers in 2010 from Government of India for his contribution in teaching and research in various domains of polymer and rubber science and technology. He has published more than 120 research papers in reputed international journals, filed 2 Indian patents and delivered several plenary, keynote and invited lectures in international and national conferences and faculty development programs. He had authored 7 books so far and 2 more are in the pipeline. He has a strong connection with several industry houses, did both government and industry-sponsored research projects and offered industrial consultancies regarding development of several products. He has supervised 15 students so far for obtaining their doctorate degree and 10 more are currently doing their research under his supervision. His research interest includes polymer blends and composites, polymers, nanocomposites, hyper-branched polymers and polymer 3D printings. Welcome, sir. Now, Mr. Kamal Chaudhary. Mr. Kamal Chaudhary, a renowned industrialist, was elected as President All India Rubber Industries Association from 2016 to 2018 and Director South Asia Rubber and Polymer Park. At present, he is the Managing Director MKL Polycot Private Limited, 173 MG Road, Kolkata. His company has now emerged as one of the major industry players of rubberized textile fabrics in India. They are manufacturer, exporter and supplier of tent, flooring canvas fabric, fire retarding neoprene rubber, rubber coated glass fiber fabrics, biodegradable fabrics, laminated fabrics, rubberized fabrics, etc. He has manufactured a lot of range. They also added new products like non-woven fabric and narrow woven fabric in their integrated plant. He is philanthropist and social worker also. Welcome to in panel, Kamalji. So now we are going to start the questions from panelists. So with your permission, I am. Sir, you have been leading a government institute under Ministry of Commerce and Industry for more than a decade. You have set policies for rubber industries, audited them for quality consistency and global competitiveness. Associated with both tire and non-tire industries in bigger way, what do you feel Indian rubber industries lack in terms of skilled manpower resources, and how do we fill the gap by educating students of academic institutes in an efficient way?
Yeah, good afternoon, everybody. First of all, thanks to the organizer for having organized this wonderful panel discussions. Coming to your question, basically, yes, I have been associated not 1 decade, more than 2.5 decades actually. It's okay. Almost 27 years in rubber industry. And very vital, what you said is good, that skill is the one, because basically very, very narrow down, in the sense basically what is required by the industry is not taught on the colleges. Barring except one or two colleges, maybe IITs like rubber technology. Even after rubber technology things, they go to the industry and learn a lot of industrial practices. So what is the problem is basically the academics are taught basic sciences and technological things, whereas the industry requires something in advance. For example, the sense of quality. The sense of quality is never taught. Basic requirements of the quality management system, which like quality management system, laboratory management system, the same thing has to be even implemented in the institute level. What is calibration? What is annual maintenance of equipment? These are the basic things. Once they get into the industry, they just straight away they are expecting them to do that. So the knowledge is about the subject is wonderful, they are able to do it. Whereas the industry needs an industrial way. So for that, they need to undergo almost 1 year to 2 years on the job training. So that takes long time. So the output from the student, they are expecting from the day one. Another problem is that they recruit graduates, fresh graduates, either graduate engineer trainee or MTs. 1 or 2 years they give a training, intensive training, and then they leave the industry and go to the other industry. So by that time, so that means they are giving you training and you are leaving for the higher package. So these are the basic problems which we come across. Obviously, it has to go on basically. What is probably like IITs now, earlier it used to be 1.5 years course when we were there at MTech. 1 year in the course of 6 months they go to the industry for project work. Now I think they have made it to 2 years basically. So 1 year that internship, or you call it as a project, something like that even for the graduates, BSc and MSc also should be there basically. And the industry should come forward and sit with academics, establish their research centers. For example, Akron University has Goodyear Research Center there. Like that, the industry should sponsor the academic institutes and they should come with their problems and give them some funding and self-finance research basically. Everything government cannot give the research things basically. When the government gives the research, more it is related to the academic research, basic research, fundamental research, which leads to a publications and patents, and that's it. Patent also is very rare, but mostly publications and award of degree, PhD, etc., etc. But it never been part of the industrial practices. Whereas if an industry comes forward, which normally IRMRI does that actually, when industry comes with the problems, so we conduct research for the need of industry, and if the industry is satisfied, the industry is, that means the sponsorship of the research is fulfilled. And while doing so, the student gets much exposure to do that actually. So these kind of things has to be much more interactive. That is why the enhancement of academic industry relationship, this kind of program should be a mandatory for every college, whether it is university or the college or anything. In all the respect, if they are able to have it, it would be more fruitful, and finally the students can get more benefit out of it. So these are the things, probably we are in the right way, but it has to be made it mandatory and more facilitated. It has to be facilitated with the system of academic course. Otherwise, they don't do it.
Yeah. Mr. Rajkumar, I am representing industry here. I want to ask you, as you say, they have to have some join some industries. That is after the course or during the course?
It could be there mostly after third year or something like that. The 3/4 course should be completed. The 4th year, suppose if it is a BSc, the 3rd year. If it is MSc, 2nd year. MTech, 2nd year, which they are already into it. So there, that could be even sometimes what happened that some of the universities I have seen, the students, they want a higher package as a standard of that institute. But when they get into the industry, they are not able to deliver what they expect. And sometimes it becomes disparity. A more experienced, underqualified, more experienced, deliver better. And here they come with ego. I am well qualified, better M.Tech, PhD, but they don't learn from a BSc or a B.Tech, highly experienced person. So this kind of class is there. And then they say that basically, that experience they should respect. That is where the lacuna is there actually.
That's why my request to you, maybe when they start study, they start their courses at that time, the academia joined with them. And maybe they have some basic knowledge with the academia, and during the course also they can visit
Yes.
our industry also. I think that is the better way.
Yes. So industrial visit, and industry should visit academics. Both should be there actually. And in fact, you should have more industry persons as a visiting faculties. Visiting faculty or visiting, researchers, like that they can come and have some 1 or 2 hours lecture and give some statement of problems and then go. And then they can come and interact for the further profile of research basically. That's how it can be facilitated actually.
Make some ecosystem.
Ecosystem like that actually.
So, one more thing I am asking you, Dr. Rajkumar. In your speech, you told that in your directorship, you have made almost 40 MOU with a lot of colleges, but maximum not come back. So, what is the reason behind that? Have they are not infrastructure to make all these things, or what is the main reason behind this?
The reason is that there is no mandatory. And they don't want to help students. Student has to pay and then come for their degree, that's it. But you see, having one interaction, these kind of things, give lot of outlook for the students. Then they conduct n number of lectures. Because, the faculties may not have that exposure to the industries. So the faculties also learn out of these sessions basically. And then faculty development program also should be industry and academic interaction program. So the faculty should know what industry needs, and industry should demand what the student needs to be, and then they should bridge this gap actually. So these are some of the initiatives which
I
we
think
should
the
do.
direction will go from the industry itself.
Yes.
That is the best way.
Correct. I used to get many calls from the industry. Dr. Saab, आप अगर एक आध students है तो बताइए. We are looking for 1 or 2 candidates who has little exposed to the basic laboratory things. Believe me, they cannot answer. Some of them are just for the titration. After BSc, MSc also, some of them very poor actually. I don't know how they pass. Later on, when we say that, tell them that we have to give intensified training in the laboratory. Because we are all in the commercial laboratory, we cannot afford to have any ordinary student to do any test or experiment actually. So we say that you come and learn as a trainee for 6 months to 1 year, then we put them into the actual practice of laboratory test basically.
Yeah, that's I also agree with you, because I also in search of not 1 or 2 students, I in search of 10 students, but I not got any up to the mark. So I'm also worried about this. So anything you give some message to the students to take care of all these things?
I think I gave enough in the morning also. The point is that whatever you learn, bring it to the practical reality. It is not just for the sake of passing the exam or getting the score of your this thing basically. And you remember, we saw lots of problems in differential equations, partial differential equations, integration, differentiation, then matrix, determinants, so many things. Do you know where these are practically used? People think that like we avoid that, that's why we came to the chemistry.
You can't avoid in physical chemistry.
Exactly. But physical chemistry, you go to the finite element model analysis. They solve that, to solve one equations, number of, mathematical applications, applied mathematics comes into pictures. I have seen solving one problem, all the mathematical learnings was applied. After doing all the solving problem, in fact, one of the professor from IIT, I attended a course out of my curiosity, though I am not an engineer, I attended that course. Why I am telling is that just see that whatever we read is coming to the applications. So after all completing the solving one problem, like 4 classes he took, finally you don't need to do anything, the software does it. The software does it behind the screen. But what do you need to know? How it solves. That is what he taught actually. So after that, if you understand that, if you are able to solve, so one problem you are taking 4 classes to understand. And like that there are numerous equations are to be solved for solving one problem of finite element modeling. And then give approximate solutions. It's not exact. Approximate solutions with your practical demonstration. So lab versus actual. If you are able to coincide, find out that when you are so close to that solutions, you are so happy. That is what they say. So you learn certain things, you never know what is that applied for. Just learn, just for the sake of scoring, first standard, second standard, graduation, post-graduation, PhD, degree, then college, and then get on. But when we come to this kind of system, industry, when you are with the industry, you will have practical applications, which needs to be brought it. Otherwise, you will be learning a lot of things without any meaning. That is what we need to bring in actually.
Thank you, Dr. Rajkumar. I hope the students will keep in this mind and do accordingly. Thank you, sir. Now I am come to Professor Naskar. So, welcome to our panel. Professor Naskar, I am asking you, you belong to an institute which is known to the world as a continuous supplier of the best technologists to the consumer sectors. You also chair a center of interdisciplinary stream of rubber technology which is exclusively existing at IIT Kharagpur. Many stalwarts have passed out from RTC, IIT Kharagpur and serving rubber industries with pride. Do you think the syllabus or research project output from your center have been apt to the need of modern world need of rubber industries? What advice you would like to give the young students doing graduates or postgraduate studies here at this college to commence a great career of industries?
First of all, thank you very much. I think I'm audible. Thank you very much for the question and compliments to the organizers, IRMRI and Scottish Church College. For me, it's homecoming after 30 years. So it's a great feeling really nostalgic. And of course, 30 years back, I was on the other side. And now when I sit here, I see the future of India, right? But I didn't miss the connectivity with Scottish Church College because for last 5 years, I think at least 1 or 2 students from Scottish Church College became our students. They are doing their master's degree. I could still remember the name. I think it started with Shayon and then I think Shubhosri. This year, my student Abrodeep just started his master project work in Pidilite industry. So that is one of the good thing about IIT Kharagpur. I don't know how many of you are aware that IIT Kharagpur is the mother of all IITs. Okay, so and this year is very special for us because we are going to celebrate the 75th year, the Platinum Jubilee celebration, and we'll be having we do have a lot of plans for organizing many conferences which will last for another 2 years' time. And our center, I think Dr. Rajkumar also did mention in the morning that Our center was established in 1981 under the leadership of Professor S.K. De, who was also the student of Professor S.R. Palit. Titas did mention that Professor Palit was also alumni of Scottish Church College, and he was father of polymer science and engineering technology of India, I would say. So our Rubber Technology Center is a very unique center, and as you mentioned correctly, it is quite multidisciplinary. And our research, our teaching, orientation, our syllabus, everything is very, very, as per the need of the industry. And since its inception, we did develop a strong collaboration with rubber industries, and that is very important, not only rubber industries, but polymer industries. And that is why I think you could see our students are having very important position, and they are doing very well in different industries. I just would like to start with IRMRI. You could see that our director of IRMRI is our alumni, and I think students from our center are there. At least 4 or 5 students are there already for many years, and we do have our students in various industries. It could be tire industries like JK Tire, MRF, CA Tire, Ralson, Yokohama, you name it. Our students are there, or non-tire industries like JK Fenner, or it could be Pidilite or Asian Paints, Jason, Apcotex, Reliance, Lances, Akzo and SI Group. Fenorchem, I think also Tamshuk, I think is one of your students, and he's doing very well in Fenorchem. So as I mentioned already, we do change our syllabus according to the need of the industry, and our alumni are our strength, and we are having very strong touch with them, and they do suggest that what could be done for future. I just would like to mention few of the things related to the research, and I think our research is very much industry-centric, and we do encourage to pursue the projects what we get from the need of the industries. So that is why you could see that a lot of projects come from, which are sponsored for 3 years by CA Tire or Apollo Tires or JK Tire or even Lances. And our research is, also it is aligned with the topic for today, which is sustainability. So for last 10 years, I think we are doing a bit with a lot of things related to chemistry, which is green chemistry, Vitrimer chemistry, chemistry related to sustainability, because, rubber technology is basically an art of science and technology of doing both chemistry and technology, right? So it is very important, and we do need the understanding of chemistry, and that chemistry has to be applied for technological developments. And there are a lot of legislations which have come up in the direction of sustainability and like REACH specification and things like that. So there are needs for a lot of people who know very well chemistry, like figuring out alternatives to many of the rubber chemicals which are toxic in nature and things like that. Like there is an agent called 6-PPD, which is kind of anti-ozonant for rubber industries. And it is reported that many of the, when you release that in the aquatic lives are getting disturbed, many of the salmon fishes are dying because of this, this thing. Or for example, zinc oxide is a very simple chemical, but it is essential for rubber industries. And there is a strong influence of this liberation, the disposal of zinc oxide in the aquatic life. So we should be very concerned about sustainability, and our center is aligned to this research in this direction. And of course, I am doing quite some stuff with thermoplastic elastomers. It has been also uttered by Mr. Jain, which is a kind of hybrid materials between plastics and rubber, because rubber has got its unique properties like elasticity and things like that, but also the reprocessability and recyclability is challenging, and that is why this kind of materials are important. And the kind of strategies like 3R strategies, reuse, reduce, and recycle, these are the talk of the towns. And there are a lot of developments towards polymerization methodology. New developments are coming up towards selection of new ingredients, new initiators for polymerization, and our research is aligned to that. So I think we would say that we are very well connected to the industry, and we continue our collaboration with industries, and our students are getting very good positions in different industries, and our syllabus, whatever you talked about, are very well aligned with the need of the industries. That's it from my side. Thank you very much.
So one more question, sir. If a lot of students are here, they're supposed to come in IIT Kharagpur, so what they will do their homework before going to there?
Yeah, I think they are doing well, and they also, you know, rubber chemistry and technology is a completely different, you know, understanding. You need understanding. So, but I think they are very quick learners, and they are picking up the subject very well, because as I mentioned, it is not only about chemistry, but also you have to understand and apply the technology. And that is, and our, I would say that our lab, our Rubber Technology Center lab is almost like a mini industry. That is our benefit. We have everything what you can imagine related to the industry, and all the equipments, kind of characterization techniques, whatever machines you can talk about, we do have. I think they are doing well. They are matured enough. I don't have to explain, and I think they are also connected with their seniors. And my best wishes to all of you. I hope that I could see you, some of you, in near future at the green campus of IIT Kharagpur. All the best to you.
Mr. Naskar, I have one question to you on behalf of industries. You just tell us in your speech that most of the research or R&D what you are doing basically for tire industries. That is, we call it big industries. So
I didn't say that. I said
no,
that it
I
is
meant
for
to say most of them.
Okay.
But like MSME, like we are, this association is dealing with MSME, mostly small and micro industry.
Yeah.
So why they are not coming to you or attaching with you regarding the same thing?
Yeah.
There is something like affordability. What is the reason behind it?
No, I can tell you that your point is correct. But last year, you are aware of CII, Confederation of Indian Industries. Last year, I think we have MOU also with CII. And under the umbrella of CII also, the industries under MSME are welcome. I think they have already started. So I think we already started and more to come. Yeah? We already had a meeting, and I think also one of the Anubhav Saxena, I think a few months back, Dr. Anubhav Saxena from Pidilite Industry, who is one of the CII member, I think steering committee member, he visited us, and I think more discussion is going on, and definitely MSME industries are also most welcome, and we can start up our consultancy work with you. No problem. Yeah.
Thank you, sir. Now I am asking some question to Sri Kamal Kumar Ji Chaudhary. Sir, being from textile industry, you know the huge demand and supply chain of such technical products to various essential service providers like healthcare, defense industry, nuclear sector, mines, etc. You also do travel to many neighboring countries to explore what's happening out there and try to adopt good practices in India to maintain a benchmark. What do you think Indian academia needs to exercise in educating and training their students to take Indian industries to the top of the ranks so that value chain is well served?
Fine. First of all, thank you for having me here today. It's an absolute honor to sit in front of a room full of young, energetic minds that will shape the future of India and simultaneously world also. We are one of the pioneer manufacturers of polymer coated textile fabric under the brand name of Jyoti, which is one of the major part of technical textile sector. Our industry started in 1965 with coating of rubber on cotton textile, and now latest moving to coating of PVC and polyurethane on various types of polyester and nylon fabrics for soft luggage sector and rainwear and umbrella sector. Now we have the first plant in eastern India to manufacture any type of composite of textiles with polymer for various applications in various industries and its allied products or solutions such as protective garments for industry like ONGC for oil exploration, high altitude garments fabric, where the temperature is very low, chemical industry, where we need the garments with chemical resistant garments, nuclear plants, where we have to resist with the radiation, ballistic jackets, that is bomb squad garments and bulletproof jackets also, firefighting garments and many more. So now I just tell you, students can also participate in this our protective garment industry and also its technical textile raw material. Now for the student, I want to say that design innovation, design protective gear, students can design and develop innovative protective garments such as helmet, mask, suits, gloves and other items to cater the various industry needs. Material science, student can research and develop new materials that can offer improved protection, comfort and sustainability for protective garments and its raw material. Research and development, researching industry trends, student can conduct research on the latest trend, technologies and standard in protective garments and its raw material, identifying areas for improvement. Developing prototypes, student can create prototype of protective garments and its raw material, testing and refining their designs to meet industry requirement. Collaboration internship, industry partnership, student can collaborate with industry partners to gain insight into design, development and manufacturing of protective garments and other textile goods. Internship, student can participate in internship with companies that specialize in protective garment, gaining hands-on experience and industry knowledge. And now the last is entrepreneurship. Startups, student can start their own venture, developing innovative protective garments or its raw material that address specified industry needs. Product development, students can design and develop products that integrate protective garments with other technologies such as sensors and wearable devices. Skill development, learning industry relevant skills. Student can acquire skill in areas like textile science, material engineering and product design, which are essential for the protective garment industry. Certification program, student can participate in certification program that focus on protective garments such as those offered by industry association or professional organization. By participating in these ways, student can contribute to the development of innovative protective garments, gain industry relevant skills and pursue career opportunities in this field. I want to talk to you about something that close to my heart, entrepreneurship. Not just starting a business, but the mindset that drives it. The courage to create something from nothing, the resilience to fail, learn and start again, and most importantly, the desire to solve real problems. Now I know the word entrepreneur might sound intimidating. We often imagine tech geniuses or billionaires on magazine covers, but the truth is, entrepreneurship does not begin with a $1 billion idea. It begins with a spark. Small problem you want to solve, a skill you want to share, or a product you wish existed. Did you know that Dhirubhai Ambani started by selling snacks and petrol in Yemen before launching Reliance? Kiran Majumdar Sao began Baikan in a garage, just rupees 10,000 in capital and zero experience in biotech. Steve Jobs built the first Apple computer in his parents' garage. Jan Koum, who founded WhatsApp, grew up poor and used to sweep floors before building a multi-billion-dollar app. Each of them started small. What set them apart was starting at all. We live in a time of unprecedented opportunity. You can start a business from your own dorm room. You can sell to the world from a smartphone. You can test, fail, learn, pivot faster than ever. The barrier have never been lower, but the competition has never been higher. That's why it is not just about starting, it's about staying in the game. Entrepreneurship isn't about waiting for the perfect time. It's about talking small, consistent action. Start now, build something. If it's small, even it fails. Because in every failure, you will find a new version of yourself, stronger, smarter, and more resilient. In closing, let me say this. You don't need to wait for permission. You don't need to be perfect. You just need to start. And one more thing I want to add here, that in our rubber sector, our per capita consumption in India is now 1.2 and the world average consumption is 3.2. The China now it is 8 kilo. The unit is kilo. India is now 1.2 kilo. And the other developing country it is now more than 13 kilo. So out of this calculation I can say we have much to grow more faster and more higher. So this value chain, now we have to focus how we can how can we reach much earlier and much convenient to this to target this figure. And in last year, I tell you the Indian rubber product export from India it is around $776 billion in 2024. And I want to tell you, in 2017 I was a delegate to China from India, from our association. And during their conversation, I asked them what is their revenue for 1 year for the rubber export. It was around 12 lakh rupees in our currency. And we are now just 10% of it. So in that, we count this difference, we have to much go higher and we have to more faster. Thank you. Thank you again.
Thank you, Kamalji. You have not left anything for us. Thank you. Now I am coming to Mr. Sandeep Mitra. Your question is how on global requirement seals students can play a pivotal role in silicon industry, especially in healthcare, home care, EV and T&D.
Okay. So first of all, again a big thanks to the organizers and inviting me to this panel discussion. So is a very valid question. Basically, now everybody knows the term of government of India is called Make in India. So maybe a question to the students interested behind, do you know what is called PLI? What is a PLI scheme? I explain. PLI scheme means Performance Link Incentive. This is a new scheme for the industries that Government of India bringing. It means you produce an EV car or any item, then what is the percentage of domestic value addition? The higher the domestic value addition, the higher the government will pay as an incentive. It means most of the industries, automotive, healthcare, they want to use local make products, locally manufactured products. That will boost the economy of the country. You now know that India had attacked Pakistan recently, and most of the weapons in our defense sector are now Indian make. So how even the ISRO, you have seen in my presentation, most of the parts are made local. How it is possible now? Because India has a very, very good academics and industrial balance coming up all over the parts of India. Probably it is a lack in West Bengal. We are still in a doubt. The two verticals has to be more collaborating, because the future is very bright. And since I am representing an Indo-German company, it is very clear for me to say that we have 2 production units in India and 4 production units across the globe. So if a customer demands come, how do we manage? The customer can order something which is available in Wacker, Germany, but it doesn't fit the economic structure of India. So simply the price is too high. So then what we do technology transfer, but to absorb that technology we need to have the expertise in domestic level. So we in Wacker Metroarch, which is a JV of Wacker, we hire students from Calcutta University, students from Jadavpur, students from IIT also. Dr. Santude is a student of IIT. So we really have very good knowledge. The only thing that this is becoming more and more challenge. The global products, the monopoly products of every company like Wacker, Dow, Momentive, Sinetsu, everybody has few monopoly products. And under this Make in India, now even government has said that only taking something out and releveling is not a Make in India. It has to be manufactured in India. If we don't do it, then everything will come from China, and we will put a stamp of lion on top of it and say it Make in India. It is not a Make in India. So to do it, Make in India, to combat with Chinese aggression, the strength is very important to understand the global requirements and transfer it to the domestic level. What we do, we get a technology from Wacker, and then we use our brains to use local fillers, local polymers to make a most cost-effective and profitable rubber. That is how we are surviving. So this is a very big message, and students is the more towards industry, because sometimes I see people are confused because this transition is very important. Whenever we take interviews, people are not quite sure whether I will do for academic or I will do for industry. Okay, this is a big confusion. Even I had that confusion when I joined Wacker. But it has to be come out, because the delivery in any form is important. Either a teacher or a professor or a person successful in industry, everybody contributes. Thank you.
Thank you, Mr. Mitra. Now I want to talk with Professor Abhijit. Sir, I'm asking is that will you once upon a time we have seen the best polymer technologists have been produced by Rajabazar Science College, and they have glorified renowned polymer based companies across the world by their wisdom and skill. What challenges do you see in present and upcoming time for students to adopt the dynamic need of industries? Apart from theoretical and practical training, are you planning to provide any industry-specific skill-centric training to students for meeting the practical expectations of industries?
Thank you. First of all, good afternoon, and thanks for the invitation. Thanks to the principal ma'am, Dr. Shourav, Dr. Basu for the invitation. My department is Polymer Science and Technology at University of Calcutta, which is under Applied Chemistry Division. Then the division itself is 110 years old, even more than that. And our department offering this degree since 1968, when there was a bifurcation. I think chemical technology, as a part of chemical technology, there was a specialization in polymer science and technology, and it trifurcated eventually in 1981, coincidentally with RTC, same year. When that Rubber Technology Center was established, our department was also established as an independent department in 1981. As Mr. Jhawar mentioned that regarding the challenges, now challenges were there even in the past, also in the present. So you cannot ignore the challenge of placement of the students in industry. Now, with time, the challenges has, it has changed its dimension or color, etc. you can say. But what I can say that, as Dr. Rajkumar mentioned, that regarding those points, that actually his points was to create a very diffusing interface between industry and academia, that you don't want to say very sharp interface, right? So you want to have a very diffused interface, which we call it as a good interface, right? So for that interfacing, what Dr. Rajkumar mentioned, our department is practicing since its birth, I can say. We have, as I mentioned, that we must have this training, industry training as a part, as a mandatory part of the course. We do have that. And even when I was a student, I did my training during my BTech in Dagbak, right, for 3 months in our final year. So it is still in the syllabus, and we have now modified it to 1 semester. The final semester, in the 8th semester, we do not have any theory and practical classes, and we do allow our students to do internship from industry. And MTech, now it's a 2-year course. The final year MTech, they are now being sent to industry for their project. We hardly keep them in the department and ask them to do project in the industry. Almost all of our MTechs are now moving out to industry for their projects. So this way we are trying to make them adaptable with the industry culture, because that culture is very different from academics. So that industry orientation, alignment with that culture is very important to adopt. Otherwise, what we see, in fact, for few students, that once they are placed, after a few days they become impatient and they want to come back. Right, sir, আমি থাকতে পারছি না, I want to go back. So we also see these sort of students, and we all know that we deal with polymer, and we know that there should be always a distribution, right? So all molecules cannot be same. So here also we also see that various types of students, but obviously this, your connection with industry regarding their training, and also intermittent industry visits. We also have that provision. We take students to industry for visit to see, how industry functions, and that is not in the final semester. In the early, say, 2nd semester, 3rd semester, like that. We do have that in our program as well. So this is what, and also Dr. Rajkumar mentioned regarding faculty. We do have all our guest faculties from industry, right? So that is another way to connect with the industry, because in a very simple way, if you do not give importance to industry, they will not also be interested to, take your students, right? So it should be a both way. And regarding that course, making it more industry oriented, every 3 years we used to change our syllabus, and we used to put more relevant topics. We deal with the entire polymer fraternity, so it's not only for rubber, we also do modification for plastics, fibers, and other products as well. So that is also on that syllabus modification in 3 years. And while we do modify our syllabus, we used to consult our industry alumnus, and we take their views, what they are actually wanting, and accordingly we used to modify. And Dr. Rajkumar rightly mentioned that we do not stress on that laboratory management system and quality management system, QMS and LMS, but we do teach them testing characterization part, but not that part. So what we are thinking of including that in our next modification, the discussion has already been done in the department, that we will be including that as well. But one thing I would like to comment, that even if you, teach everything, every aspect, right, even then you will not be able to make them industry ready completely, right? That is not possible, right? Because these are the 2 different domains. So you cannot make them completely industry ready so that they will start serving from day 1 to industry, right? So, and I think for that we have a provisional appointment model where we, industry actually make them adaptable with their own system. So it is there as well. Because when there is recruitment, I think Mr. Mitra will agree that they don't also expect that student will answer everything. Right?
Sure.
So
exactly.
So what they actually, see the approach of the student,
Right.
how much practical it is. Because in technology, we don't practice rigorous science. We need the contribution, or rather application of common sense. So if you are very sound in common sense, then you will be a very good technologist, right? So that is very simple way. So because if your technology is a complex one, then it will not be popular. People will not be, it will not be accepted by the mass. So the technology has to be simple. Just you take the example of your phone. When it was the Windows version, you see, when it was Windows version, it was so difficult to run a phone, but now it is so easy, this Android version, that Windows version is out of the market. So technology has to be always simple. So it's a practice of common sense with the background of what you have learned, that little bit of science, I would say. So that is, from my side, what I've tried to convey. And again, once again, thank you very much for this invitation and giving me opportunity to speak before you. Thank you.
I would just like to add a few things to Professor Avijit's comment. WACKER is one of the big example in Calcutta. I would say I think every alternate year we hire students, and I must mention that it is the culture which has changed, and also industries need brains from the academics. This is the bottom line of everything. And sometimes we also, during the interviews, we argue whether we would take a industrial experienced person or a fresher. But if you see, most of the consultants, they go with the fresher because the energy is there. That is the first thing. The second thing, it also depends on the mentality. Who wants faster adaptation, right? So it is very difficult, because I also came from Jadavpur. We had many courses, but it is not possible to educate a student in industrial culture. So we also, and also one very important thing, that in industry there are various departments. There is procurement, there is quality control, there is production. So when I joined, my boss said, you came holding a test tube, so you will first want to do R&D. Then when you mature, you will say, no, I will do technical service. I want to go to customer. When you further mature, you will say, I want to go to sales because there is money. So this is how things changes in life, the priorities. So when we took Himadri, I was just arguing he cannot be fit in our procurement, but now he is the head of procurement, because then I told that how a chemical engineer do in procurement, but then we found that he's the best person to judge which chemical to purchase. So it means that this is very important, and normally we have probational period where we judge the interest. So first we hire students, and for 6 months to 1 year, we see which student has interest in which department. Somebody is more better in talking to customer. Someone is a shy, wants to do accurate testing, could be good for QC, and so on. So it always is not that industries want like a switch. You buy a washing machine and you plug in and it will start. So it's always, but this exchange, and WACKER do CRO projects with ISER and with IITs. So that is also funded, because we have our problems and we have limited knowledge. We only know what we are practicing every day. So that is not our job to find out a solution. That's why we rely to do this exercise by CRO.
Right, sir. So now we are concluding the, okay, yeah. So anybody want to ask some questions from our panel? Yes.
Good afternoon, sir. Am I audible? Good afternoon, sir. So, as you have said sometimes ago, that okay. So can I speak in Bangla if you are? স্যার আপনি যেমনি বললেন কি মেড ইন ইন্ডিয়া, আমরা সবাই এটাই ভাবি, এটা একটা খুবই বড় প্রশ্ন কি মেড ইন ইন্ডিয়া গভর্নমেন্ট তো শুধু প্রমোট করছে মেড ইন ইন্ডিয়াকে, কিন্তু আমরা যদি ঠিক করে রেখে ম্যাক্সিমাম এমএনসিস যারা ইন্ডিয়াতে আসছে তারা শুধু একটাই জিনিসে ইন্টারেস্ট কি ম্যানুফ্যাকচারিং প্ল্যান লাগাও, প্রোডাকশান ইনক্রিজ করবো, R&Dর জন্য ইন্ডিয়াকে কেউ দেখে না। এটা কারণটা কি? ম্যাক্সিমাম ইভেন টাটা কেমিক্যালসের মতন কোম্পানিও নিজে R&D বাইরে ইউএস সুইডেন এখানে ইনস্টল করছে। ম্যাক্সিমাম ফার্মাসিউটিক্যাল যারা বাইরে থেকে এখানে আসছে তারা ম্যানুফ্যাকচারিং প্ল্যান্ট এস্টাবলিশ করছে, কিন্তু R&Dর জন্য ওরা আবার বাইরেই চলে যাচ্ছে। এটা কারণটা কি? কারণ কি আমাদের অ্যাজ আ কেমিস্ট ম্যানুফ্যাকচারিং একটা কোয়ালিটি ছাড়া কেমিস্টের কোথাও আমার মনে হয় না কি কোনো রোল আছে। R&D যেটা সব থেকে ব্রড ফিল্ড সেটা তো ইন্ডিয়াতেই নেই।
আমি আনসার দিচ্ছি। হ্যালো, আমি বাংলাতেই উত্তর দিচ্ছি। ব্যাপারটা হচ্ছে এটা কোম্পানি টু কোম্পানি স্ট্র্যাটেজি ভ্যারি করে। ফার্স্ট অফ অল তোমাকে প্রশ্ন করছি, ভাবো তুমি একটা ইন্ডাস্ট্রি রান করছো, R&D সেট আপ করা আর ম্যানুফ্যাকচারিং সেট আপ করা কোনটা বেশি এক্সপেন্সিভ হবে বলে মনে হয়? ন্যাচারালি R&D ইজ দ্য কোর স্ট্রেংথ। ঠিক আছে, দু ধরনের কোম্পানি হয়, এক যার অরিজিন লাইক ওয়াকার, যার অরিজিন হচ্ছে একটা ফরেনে, তো ন্যাচারালি তাদের কোর R&D ফরেনেই হয়। ম্যানুফ্যাকচারিং যখনই কেন লোকালাইজ করতে চাইছে, দুটো কারণে। একটা আমি বললাম যে PLI স্কিম অ্যাচিভ করার জন্য আমার কাস্টমার মেক ইন ইন্ডিয়া মেটেরিয়ালই কিনবে, তো সেই জন্য ম্যানুফ্যাকচারিং। সেকেন্ড হচ্ছে ওভারহেড কস্ট ইন্ডিয়াতে অনেক কম কম্পেয়ার টু আদার কান্ট্রিজ, সেই জন্য মেক ইন ইন্ডিয়ার হিসেবে ম্যানুফ্যাকচারিংটা হচ্ছে প্রায়োরিটি হয়। কিন্তু ইন্ডাস্ট্রিতে দুটো টার্ম চলে, একটা হচ্ছে R&D আর সেকেন্ড হচ্ছে প্রসেস কেমিস্ট বা টেকনিক্যাল সার্ভিস। এরাও কিন্তু কেমিস্ট। ইভেন আমি যখন আমার কেরিয়ার স্টার্ট করেছিলাম, আই ওয়াজ আ প্রসেস কেমিস্ট, উইচ ইজ আ কম্বিনেশন অফ কেমিস্ট্রি অ্যান্ড কেমিক্যাল ইঞ্জিনিয়ারিং। তার মানে R&D মলিকুলার লেভেলে তখনই কাজ হবে ওয়েন ইট ইজ আ লং টার্ম প্রজেক্ট। কিন্তু আমাদের যে শর্ট টার্ম প্রজেক্ট, তার যে কেমিস্ট তারা কিন্তু সমস্ত ম্যানুফ্যাকচারিং ইউনিটেই বসে। ইভেন ইউ নেম টাটা, ইউ নেম অ্যাকজোনেবল, ইউ নেম বার্জার, এদের সকলেরই কিন্তু কেমিস্ট প্রচুর পরিমাণে আছে, হু আর রেসপন্সিবল টু টেক অর কপি অর ট্রান্সফার এনি টেকনোলজি। মানে ইট ডাজেন্ট মিন যে ম্যানুফ্যাকচারিং ইউনিট হলেই শুধুমাত্র সেখানে R&Dর বা সেখানে কেমিস্টের কোনো দরকার নেই। কোর R&D বলতে যেটা বোঝানো হয় দ্যাট ইজ জেনারেশন নেক্সট প্রোডাক্টস। জেনারেশন নেক্সট প্রোডাক্ট মেবি অ্যাট দ্য মোমেন্ট ইন্ডিয়ায় দরকার নেই, লাইক EV। ইন্ডিয়াতে EV অ্যাডাপ্টেশন রেট টিল ডেট ভেরি লো দ্যান দি এক্সপেকটেশন, ইভেন আফটার আ লট অফ পুশ। তো ইন্ডিয়াতে ইভেন 4-wheeler EV ইজ ভেরি লিমিটেড, মোর ইজ 2-wheeler অ্যান্ড 3-wheeler। তো সেই জন্যে ওয়াকার যেটা 4-wheeler জন্য সিলিকনস ডেভেলপ করে, দ্যাট ইজ নট নিডেড অ্যাট দ্য মোমেন্ট ইন ইন্ডিয়া, বাট উই নিড 2-wheeler অ্যান্ড 3-wheeler প্রোডাক্টস। তার জন্য উই হ্যাভ আওয়ার লোকাল টেকনিক্যাল ডেভেলপমেন্ট, লোকাল কেমিস্ট, লোকাল টেকনিক্যাল সার্ভিস, দে আর অল কেমিস্ট। তার মানে এটা মনে করার কিছুই নেই যে ইন এ ম্যানুফ্যাকচারিং সেট আপ ইউ ডোন্ট নিড এ কেমিস্ট।
Role of advanced materials and nanotechnology in rubber enhancing practice for industry.
Role of nanotechnology and advanced material. Okay. Nanotechnology you want to know?
Yes, sir, advanced materials for nanotechnology.
Advanced material for nanotechnology. Nano আজকে আমরা খুব সবথেকে ভালো প্রেজেন্টেশন দেখেছি, তোমার সামনেই উনি বসে আছেন। Nanotechnology means it's in a nano level, right? তো আমরা যখন আদার দ্যান রাবার, আমরা যখন কোনো ইমালশনস বানাই, ইউ নো অল ফিজিক্যাল কেমিস্ট্রি, তো ফিজিক্যাল কেমিস্ট্রিতে একটা মাইসেল বলে জিনিস আমরা পড়ি, রাইট? তো এই যে মাইসেলের ডায়ামিটারের যদি ন্যানো লেভেলে হয়, দ্যাট ইজ অলসো ন্যানো টেকনোলজি, রাইট? তো আমি তেল আর জল আই ওয়ান্ট টু মিক্স, ইট উইল নেভার মিক্স। আমাকে ওখানে সারফ্যাক্ট্যান্ট দিতে হবে যার দুটো এন্ড, ওয়ান ইজ দ্য হাইড্রোফোবিক অ্যান্ড ওয়ান ইজ হাইড্রোফিলিক, it will form a micelle.
এবার এই মাইসেলের যে ডায়ামিটার, আমি অয়েল ইন ওয়াটার এই ধরনের ইমালশনের কথা যদি বলি, তার ডায়ামিটার যদি ন্যানো লেভেলে হয়, দ্যাট ইজ ন্যানো টেকনোলজি। এই ধরনের ইমালশন লুক লাইক আ ওয়াটার, ইজ সো ক্লিয়ার, বাট ইট হ্যাজ অয়েল গ্লোবিউলস ইন আ ইমালশন ফর্ম। এই ধরনের প্রোডাক্ট আমরা প্রতিদিন ইউজ করি। এই ধরনের প্রোডাক্ট আমরা ইউজ করি ক্লিয়ার শ্যাম্পুতে, এই ধরনের প্রোডাক্ট আমরা ইউজ করি ফেব্রিক সফটনারে, ইভেন যে হ্যান্ড ওয়াশ লিকুইডগুলো যেগুলো ইজি ক্লিনিংয়ের জন্য ইউজ হয়, ক্লিয়ার, এনি ক্লিয়ার সোপ বেস ডিটারজেন্টে কিন্তু এই ন্যানো টেকনোলজি ইউজ হয়, আদার দ্যান দ্য রাবার ওয়ার্ল্ড। তার মানে আর কনস্ট্রাকশনের কথাটা যেটা সকালে আমরা বলছিলাম, কনস্ট্রাকশন ইন্ডাস্ট্রিতে যদি আমি একটা মার্বেল আর একটা দেওয়াল চিন্তা করি, তাহলে ক্যাপিলারি সাইজ মার্বেলে অনেক সরু, অনেক ছোট। তো টু এন্টার টু দ্যাট ক্যাপিলারি ইউনিট ন্যানো পার্টিকলস, মাইক্রন লেভেলে হলেও পেনিট্রেট করবে না। সো এই সমস্ত অ্যাপ্লিকেশনসই হচ্ছে ন্যানো টেকনোলজি। সো ন্যানো টেকনোলজি ইজ এ broad word. It can be a nanoparticle, it can be a nanomicelle, it can be a nanomolecule based on its application. Basically আমরা ওয়ার্ডগুলো শুনে ভাবি it's a very new thing, but actually it is already existing in our day-to-day life. ঠিক আছে?
Thank you. Anyone else?
So, in the month of December, I went to Delhi. There was a panel discussion why Indian universities are lagging behind in compared to the world universities in quarterly Simon's ranking, QS ranking. Okay. So if we go through the details, you will find Mumbai IIT now is probably on the 118th rank, and this is the highest possible rank in India among the universities and IITs. And we are on the 78th years after independence. So in the education sector, really, in comparison to world, we are lagging behind. So I seek from the panelists the possible reasons behind it.
Just morning only I got a mail from our ministry seeking the inputs that what is the current system lacuna in academic industry interaction and why we are lagging behind. Tomorrow there is a meeting with the cabinet secretary. He is leading it. My inputs are ready, almost I am going to send it actually. And I will just, I was giving the, people might be thinking what I was typing it. I was giving inputs to my secretary and she did whatever she combined. I was just making that actually. Improving R&D ecosystem in academics. Institution, key issues and next steps. The key issues, lack of funding and resources. Is it not? Insufficient industry academia interaction, collaboration, which we discussed in the morning. Limited research infrastructure. Ineffective intellectual property management. You may have done wonderful research, but you don't know how to file the patent, how to commercialize. It is it. Lack of experienced faculties. I was just discussing in the morning. I was told that like once upon a time we had 15 faculties in this, 15-20 faculties, now only very limited. There is system just going on basically. Then lack of industry practical experience for the students basically. So key issues are identified. Now what are the next steps? We are advising it. Enhance research funding and grants. Foster industry academia partnership. Upgrade research in infrastructure. Develop effective IP policies and management. Implement talent retention strategies. Because we don't manage the talent, so they go abroad. You give the highest education in IITs and the universities. After the PhD and the things, they are going abroad and they are serving them. They are not being retained here. So that is the one part. And then recruit talented and skilled faculties is also part of that actually. Organize industry visits, which we are coming up. Then internships, which we discussed about it. On-the-job training programs to provide students with hands-on experience and practical exposure. bridging the gap between academic and industry. Probably, you know, like best college, like both the professors spoke about it, they are doing it. What about other colleges? It is not every student is having the same atmosphere as university or things. That is why those students educated in a college is different than a student who is educated in a university system or the IITs or NITs. What we need is that we need to give equal infrastructure, equal quality of education across the country, across the college. So how do we do that actually? That is what we talk about actually. So then the potential initiative grants and fellowships. Even though they are the fellows, the fellowships are available, how are they managed? We get it, but we found many times you get the grants and fellowships, but you are not able to manage the research because you don't get the right scholars at the time. And half of the research period is exhausted because you are searching for a talent. By the time you recruit, and they are asking for the intellectual property, how many patents you published, etc., etc.
Grants are also released almost after 1 year.
Yes. So there are this thing basically. So it is like government is also actively working on it. They are gathering these inputs and they are at the very highest level. Tomorrow this input will be with the secretary, chief secretary. I am telling, cabinet secretary rather actually. So that's how that all the autonomous body they keep asking it actually. So what we gave is not, it is, in fact, it is very generic. It is not meant for rubber alone. It is across the industry, across the sectors basically. And it is the same, even if you go to physics department, you will find the same thing. Go to the, history, geography, anything. Because this is where the, situation basically. So once we are able to bridge this gap, so we will be able to address this issue basically. So one is the lack of research infrastructure, facilities, and then adoption. So I said like basically in Mumbai we started from our Diamond Jubilee celebration 2018 onwards. Every year 13th January as a rubber day. We celebrate rubber day. What is that day? We open to the students and industry. So almost 400 to 500 students, they visit our campus. They come to the facility and see and appreciate. The students from chemistry, physics and chemical engineering, mechanical engineering, they never seen what rubber is basically. We make it open. Like that, I think Mr. Kamal Chaudhary just requested that they are ready to sponsor from ARIA or from his own, whatever the way, basically he is ready to do that. And IRMRA East Center will be open. You can make it any time, the students can go there and there could be an industry visit from that. Yeah, we can do the internship. Yeah. One is that you can just have an industry visit, one-day visit, appreciate what are the facilities. Afterwards, few students can go as internship. It could be a 15 days or 1 month or 3 months internship. Yes. Yeah. That could be possible. And then the project work also they can do it, like master students they can do the project work. And in fact, we also don't have or get good quality students for doing research basically. In fact, we started our MSc program with Mumbai University. 1 year in Mumbai University, second year they come to our campus. After having this program started, our IPR, I mean the paper publications or patents have gone up. Can you imagine that our own students hold almost 4 to 5 patents? And we, 60 years we had 2 patents. Last 10 years we have almost filed 16 patents and 8 got granted. Out of 8, 4 or 5 along with the students basically. So which college are the institutes that students are able to file the patents? That is the way that we manage it. So I mean that kind of spirit has to be brought in basically. Everywhere that system has to be built in basically. So finally I would like to see that basically similar that interaction. It is not that today, this year. We always, whenever any academic institute request for industry visit, I never say no. In a year almost they come 4 to 5 visits. Other than that 1 day of rubber day. The rubber day there will be 10 colleges at least, almost 400 to 500 students visit our campus and appreciate. And then apart from that we also make a lot of industry academia programs and we go as a customized training programs And they also, special program for the students, like we have association with the Wales University. They conduct, go on, our faculties go there, 1 month program they conduct. So this is an extra qualification for them to get employed. For example, if your chemistry student goes to Mr. Kamal Chowdhury's factory for interview, if they say that I am chemistry from so-and-so college, add on that I have a 1 week course or a 10 days course from IRMRI certification. He would definitely take IRMRI students rather than normal student actually. So this is the additional qualifications which you should facilitate, because students may not know that what are all such opportunities are there in the industry. Once you do such things and make them 1 or 2 mandatory, I know they spend a lot of money in going eating out and excursion, etc. But this could be very limited, 2,000, 3,000 rupees. We make it bare minimum cost. Even sometimes free of cost does not matter basically if they want, they need actually. And that kind of certificate course would tell them. You go to any tire industry, they will welcome them basically. So IRMRI certificate is good, like IIT also. So when they have that short-term course, that is an additional visa for them basically. Otherwise it is just mere passport. With a passport you cannot enter into any country. You need visa. So what we want to distribute the visas for you to get into industry. Then you prove yourself basically. So that's how we should do that. So that is what our suggestion also. The more you have interaction with the industry. Today we have some 4 or 5 industries we are here. We understand the quality of students you have it. What about other industries? They don't know. If you bring 5, 10 more industries to know that, your students will get better placed basically. That's how it can be done. Same thing with the other colleges also. If you are able to do this, definitely do that. Very simple, I'll tell you that. What you can buy in a rupee, you cannot make it in a rupee. Can you do it? I'll give you 1,000 times. You can buy it in 2 rupees. This maybe you can just get it in 2 rupees in your market. I'm asking you to think about it. But if you want to make this 2 rupees pen, what kind of capital you need? I just want you to think. Just a pin, you will get a bunch of pins for 10 rupees. But can you make in 10 rupees that bunch of pins? I'll give you 1 lakh rupees. Can you make it? Just imagine, this is how that innovation comes into picture. And this is the polymer industry. It is not just polymer industry. Most of the things are polymer industry. But you have nib as well as ink. So it is an interdisciplinary technological inventions went in, the best one. And what you got it in a cheap rupees of 2 rupees or 1 rupee. And even in that, they have 30%, 40% profit. Can you imagine even getting even cheaper? That is what China is doing. Why people are trading from China is that. Because they produce in bulk, mass, anything think mass. What we do it, just have 5 lakh rupees investment, produce some 1,000 numbers, then your cost will become 20 rupees per piece. Who will buy the 20 rupees when it is available for 2 rupees? So to make it cheaper, you need to think mass, huge. So even that we are not getting such machineries that cheap here. For getting the machinery also we are import dependent. We are getting it from China. But government is looking into it, how to minimize how to improve the competitiveness, how to minimize the cost, all those things basically. So it is one thing, just don't buy anything. Just think the amount of technology behind this to make it. If you start thinking anything, you are just running with the tires. Can you know how complex engineering science is behind that? Engineering, technology, science, everything. So to appreciate that, you need to think about it. Just think that can you make it actually. I can give you crores of, even to start a small rubber factory, you can start with some 20 lakhs rupees. But to make a tire industry, minimum capital you need at least 100 crores. After that also you will be incompetitive in the things. So that's the kind of technological advancement we are talking about. Still, we have a long way to go. So appreciate the technology, appreciate the science. All like you. Everybody is like you. No one can do wonders, but a team can do wonders basically. So that's how you can be one among like that. What we are talking about the entrepreneurship is that government is giving even up to 2 crores, 5 crores.
they will give you a very cheap rate of interest basically, encouraging you to come and do that. Only thing is that come with your own ideas, entrepreneurship, and start from the beginning and then do that. Many people do it on the computer entrepreneurship, lot of things. But bringing into the industry is a highly competitive, huge problems and things. And labor is the most problematic, of course. So if you are able to bring most of the automation, that is the computerized things, it's a huge benefit actually. That's how the things are going on basically. I think we can keep on talking, and I could start now actually. So thank you very much.
Our Scottish Church College students to go there in their lab and just keep some all the test and everything to learn. So thank you from the behalf of our principal. So
Just,
what we will make our
sir,
plan
just
accordingly.
one final point which I just kept to be mentioned in the last is that the model that we follow regarding the interaction with the industries, keeping it mandatory with the course and all, our employment record for the students is 100%. In this year, our final year students, the semester is not over. 60% of them are already being placed, and more campus interviews are due, and almost 100% will be done in this year as well.
So thank you everyone for joining us for a remarkable whole day consent here. So hope we will again manage this.
Okay, now I would like to request our principal madam for the felicitation purpose, and please ma'am, our principal madam Dr. Modhu Manjuri Mondol will felicitate Mr. Navratan Jhawar, Suncrest Industries Private Limited. Madam will be assisted by one of our PG student, Ms. Shagorika Chatterjee. Bag actually. Again, I request Madam to felicitate Professor Kingshuk Noshkar, IIT Kharagpur. Madam will be assisted by Dr. Debaruti De. And all those uttorios are made by our student, and this was preparing in our college. I'd like to request Madam to felicitate Professor Abhijit Bandhopadhyay, Calcutta University. Mr. Kamal K. Chaudhary, MKL Polycode Private Limited. Madam already has felicitated Mr. Shondip Mitra, and now I like to request Professor Nikhil Guchaid sir, he is also my teacher in university, to please come up on the stage. Our respected Madam now felicited Professor N. Guchait. স্যার একটু এদিকটা ঘুরে দাঁড়ান স্যার এদিকটা একটু ঘুরে Thank you, Madam, and thank you all our respected dignitaries. Now we will move forward to our poster session, and to conduct the poster session, we would like to request CKP Sir, Dr. Chandan Kumar Pal on the dais.
Now we are having our poster session, which is posters are displayed outside. Our judges will take note of this and judge these each posters, and after that, after say half an hour from now, that means 4:50, we shall again assemble here for the valedictory and prize distribution of the posters. The posters session will be judged by Dr. K. Rajkumar, Director IRMRI, Government of India, Professor Kingshuk Noskar, Head, Rubber Technology Center, IIT Kharagpur and our alumnus, and Professor Nikhil Guchait, Professor of Chemistry, Department, Calcutta University. Mr. Rajkumar, Dr. Rajkumar, and from there is King Shuk Noskar, Professor King Shuk Noskar from IIT Kharagpur, our alumnus, and Dr. Nikhil Guchait, Professor of Calcutta University, and our they have meticulously judged each and every poster, questioned, and you must be excited to get the marks. So these are in process. And how do you feel? Who is the winner? 13. 13 posters were there, and in today we have got many universities. We got Calcutta University, we got Jadavpur University, we got colleges outside Calcutta University, and some remote colleges are there. Saurabh, marks. So, our Madam Principal wants the poster presenters here. Can you come to the one by one? Poster number 16. Poster number 16. Are you here? Last poster. These two are from our colleges. Poster number 16. Please come here. Poster number 15. Poster number 15 from at a cordless down. Techno India. Poster number 15 from Techno India. Poster number 14. Poster number 14. Poster number 13. Poster number 12. From Scottish Church. Poster number 14. Poster number 13. Poster number 12. Poster number 11. Calcutta University. Poster number 10. Poster number 9. 10 from which? Calcutta University. Poster number 9 from Calcutta University. Poster number 8. Poster number 7. You are from Scottish Church College. Poster number 6. Scottish UG. Poster number 5. These are from Scottish. PG. Poster number 4. Four from Scottish. Poster number 3. Poster number 3. Poster number 2. And poster number 1 is absent. Raja Piyari Mohan College. So who is the winner? So poster number 9. Poster number 9. Please raise your hand. Poster number 9 got third position. What college? 9 from which college? Calcutta University.
That is perovskite. Perovskite materials.
Perovskite materials. Oidik. Please tell your name.
Devashish Brahma.
And?
Sumona Mojumdar.
Arundhati Chakraborty.
Which department? Polymer science. Okay. Then poster number 12, second.
I'm Arnav Banerjee. I am doing my PhD under the guidance of Professor Upendra Nandi in Scottish Church College. My topic is electrochemical performance and enhanced magnetoresistance of lanthanum manganites perovskites. Thank you, ma'am.
And first prize goes to poster number 10.
Good afternoon, everyone. Myself, Ritika Sarkar, and I am a research scholar, and I am doing my PhD under the guidance of my supervisor, Professor Abhijit Bandyopadhyay, and in your department, Polymer Science and Technology, and they are my co-worker. They have helped me in building my poster. So please, I would let them to introduce themselves.
I am Ishanvita Chakraborty.
I am Shayantani Bhattacharya.
And my topic is I am synthesizing architectural polymer for biomedical application. Thank you.
So before the prize will be given by our principal ma'am and the director of IRMRI. So we begin with the third prize. Sir, Professor Rajkumar. So third prize goes to team number 9. Team number 9. So give them a big hand, please. Certificate gulo lekha hai nahi to. Certificate lekha. So your certificates are due, that will be given later. Second prize goes to team number 12. কিন্তু তোমার সার্টিফিকেট থাকবে না। And the most coveted prize for the first prize goes to team number 10. So we will be giving certificates college wise, okay? And for the poster competition, since we have got, so now vote of thanks is given by our dear IQAC coordinator of Scottish Church College, Dr. Somrat Bhattacharya, please.
Let me start with the vote of thanks without further delay. First and foremost, this program would not have been possible without the active cooperation and support from India Rubber Material Research Institute, Government of India. I would like to thank our Chief Patron, Dr. K. Rajkumar. Director Sir, thank you very much for your gracious presence today. Without your active support, this program would not have been possible. Thank you so much for being with us today. I would also like to thank in absentia the Honorable Minister, Dr. Shoshi Paja, Minister of Industries, Commerce and Enterprise, Department of Women and Child Development and Social Welfare, Government of West Bengal, for her support to organize today's program. My special thanks to all the resource persons, Mr. Shondip Mitro, Dr. Titash Mondol, Shri Kamolish Jain, as well as Mr. Nabaratnan Jhawar, Upendranath Nondi, Kingshuk Noshkar, Abhijit Bandopadhyay, Kamal Chaudhuri. Thank you all, sirs, for your active presence here, for the support, for your participation in today's program. Thanks for the poster session also, for judging the posters. I would like to thank Dr. Kaberi Chatterjee for conducting today's inaugural session. Special thanks to Dr. Somali Mukherjee for conducting so efficiently today's program. And thanks to our two coordinators, Dr. Chandan Kumar Pal and our Dr. Saurabh Chakraborty. I think they deserve a round of applause, because this entire program today, it is because of their active support that we could organize. And Devdipta Basu, who from Indian Rubber Material Research Institute, the Senior Assistant Director, who guided us how to organize this program in a much more efficient way. This journey we have started, and we hope that we will be able to infuse the true meaning of skill development along with the academic excellence which the college is running through, so that you can pertain this in your life, you can effectively use this in your life to have a better future. That is our goal. Our special thanks to Principal, Vice Principal, and all the members of the Internal Management Committee, and the support staff who for the entire day was with us, Govindo as well as the photographer and his team, Gautam Babu. Thank you all. Without your active support, this program would not have been possible. Special thanks to all the participants. Without your presence, the students, the research scholars from different institutes, please convey our serious gratitude to the heads of your institutions for allowing you to participate and come to Scottish Church College. We consider this to be a family. We are very happy to welcome you over here. And special thanks to the head of Department of Chemistry and all the faculty members of Chemistry for his active support. And our sponsors, Walkers, Holdwell, Jyoti, Suncrest, and Anton. Without their active support from behind, this program would not have been possible. If I have missed out anyone, please excuse me. Have a wonderful evening ahead. Thank you.